I think we're live. Hopefully. Hello, everybody. Welcome to, here in Australia, this sunny Sunday afternoon. Today we're going to have another look at where we are with Excel Tools 2 and see if we can do some more fun things with that. So yeah, hopefully it'll be interesting and informative. So a few things have changed in here. I've actually removed my little whatever ball and chain thing that was over here. I still don't really know what is going wrong with that, why it was suddenly stretching out. But I know it's not an XR related issue, it's a setup issue. So I just got rid of it. It's not really important for what we are doing here. Just not worth right now figuring out. That all said, yeah, I think in last stream we were working on the hand logic, which is now pretty much done. So just to revisit that, most important thing, for instance, is our test box here, where we have our little grab points. So the boxes that we have here don't have grab points, or I think I've turned them off. Yeah, they're disabled. So with these boxes, I'm using my automatic placement of the hands. And there's some things that I want to improve there, but I'm quite happy with how that works right now. But with here, this test one, I did have the hands on there, and I purposely put them sideways like this instead of having the hands on the same side of the cube. And what we can see here is that we've roughly positioned the fingers. Actually need to move the hands back a little bit, I think, to make that nicer. With that one and this one too, I think. We will probably want to move that a little bit more like this. But yeah, the hand placement now completely works with the finger poses. So we have our default finger poses, or the finger poses that we place the fingers with, and then we also have our open finger poses so that we can move fingers based on our trigger and grab input. But for something like this, we don't want that. We just want the hands to be positioned as is, and that's how they get positioned. So that works. We can have a quick look at how that runs, just to sort of remember where we were with that. So let's go and run this. All right. Oh, why does that open up full screen? No, it doesn't. That was just something weird that I suddenly had my screen black out. I don't know if you guys saw that. But yeah, the game itself should now be running. Let's see if I actually not getting it in here. Why is that? Why am I not seeing it in the headset itself? Because, oh, that is why. Because Steam VR isn't my default OpenXR runtime anymore. So I'm just going to go back over here. No, here. Yeah, I was playing around with the Android one. So let's go and do that. So with that, hopefully it should now run in Steam VR. And that's probably why we had the screen, or I had the screen black out for a second. There we go. That's much better. So one downside with OpenXR is you have to have the correct runtime active. And when you have multiple headsets, that can turn to be a little bit funky. So you guys should be seeing me in the camera there. That's maybe one of the things that we should be working on today, making sure I can actually move that around. It's maybe something I'll do. So yeah, I can move that like this, but I can also pick it up. And as you can see, when I pick it up with both hands, the hands are on the side. But also I can manipulate the box by moving my hands. I don't know if the ghost hands are very clear, but it tries to sort of position the thing that I'm holding by kind of taking averages of what I'm doing here. I keep hitting my microphone. The other thing is there's some logic here. I don't know if that really shows well. I'm going to move back a little bit. My cable suddenly got stuck. So when I grab it with the second hand, you'll see that it moves in place because of this 45-degree angle, or 90-degree angle, I should say, that I'm grabbing it. And then when I let go, it sort of bounces back in its old position. So yeah, that's all working pretty well. Obviously, I can't move the box through the table. The table is a collision, so that is all working. Also two-handed, you can see that it'll stop the box from moving. Again, the other box might be a little bit in the way. Let me go and move that out of the way. Wink. So that is easier to see. But yeah, that is all working pretty good now. I'm pretty happy with that. So I'm using hand tracking, but controller inferred, which is something that Steam does really well, including the capacity sensors that will move the individual 3 fingers, which is pretty cool. That obviously is dependent on the capabilities of the runtime that you're using. We have a fallback on this, that if the runtime does not support controller inferred hand tracking, that it purely works on trigger and grip. But yeah, we've got that working. Now also, I'm wondering if I actually have hand tracking working. No, I don't think that goes with this one. Oh, of course, with this headset that doesn't work. But with Quest, that is actually something that I can do, where I can switch between controller tracking and hand tracking, which is cool. But with hand tracking, I don't have motion control, so it's something that I do want to look into at some point. But for now, yeah. Hey, Hexorina Torman. Oh, that's a full mouthful. Your name. I hope I didn't butcher that too much. Yeah, that is a Steam frame. I am doing most of my development with the Steam frame at the moment. So yeah, that is where I'm at with that part of it. And again, I think I've showed most of that on the previous stream, but it's good to sort of recap. I did tweak a whole bunch of things, so it's working fairly well at the moment. And I'm actually eager to start making more things with that and trying to see how far we can push it. Now, the other thing that I've been working on is to also be able to grab static objects. So things like, walls, floors, etc., etc. Now, one thing that I did, and this is not something by default, this is just something that will, I guess, need to be documented. But when I go to my 3D physics layers, everything by default goes into layer 1. That's the way that Godot has always worked. And this was the thing that I was struggling with before, where I sort of go like, okay, that would mean that by default, I've already made it so that by default I can grab any rigid body, which is a departure from Xrd 2, where you have to specifically inherit from Xrtools objects in order to make rigid bodies, that you can pick them up. With Xrtools 2, any rigid body in your system you can pick up, which is really nice if you have an existing game that you want to port to VR, where all your objects are already rigid bodies. Now all of a sudden, you can pick those up and you can manipulate them in a natural way. And I am working with decorators to sort of allow you to limit features there. And we'll have a look at that in a minute as well. But by default, anything can be picked up. Now, that means that with static objects, we're kind of going in the same direction. If we don't want to do, inheriting from special classes, but we want the functionality to just work out of the box, we would end up being able to grab any static object, which means that we can climb up on just about everything. So what I did there is say, well, by default, when we define, and I need to go to our pickup function here. So by default, the Xrd2 pickup function is set up to only look at layer 1. Now, obviously, this is the default collision mask. And again, collision mask is what we use to detect things. Maybe that should have a better name. I'm not entirely sure. But that's the naming convention in Godot. So this basically means that for anything that we're detecting that we can pick up with our pickup function, we're only looking at physics layer 1. Now that is, again, like I said, the default. Anybody can choose how they want to use that. In this demo, I have chosen that layer 2 is the layer that I place things in that you can't pick up, whether that's rigid bodies or whether that is static bodies. So what we're going to see is when we are looking at our world and we're looking, for instance, at our wall here, our wall is placed in layer number 2. So I can't actually grab this wall and climb up this wall by default. If I had left that in layer 1, I would just be able to climb that wall, and we can probably have a play with that in a minute. But in a similar way, when we, for instance, look at our floor, so I've also got our floor in layer 2. In theory, and there's probably a little bit more going on because of the way that we currently have our locomotion set up. But if you wouldn't be using the standard locomotion, so you wouldn't be using the raycast body specifically, because that is what keeps us off the ground, but you would set up your player differently, but you would still use the pickup function. You could very easily create like a guerrilla tag type movement in this system, and maybe I'll make a demo for that at some point in time, because it should just work out of the box right now. The only reason why it currently doesn't work is because the current system is keeping us, on human height off the ground as if we're standing up. But yeah, if the ground was in collision layer 1, I should be able to grab the ground and I should be able to move, because that's the difference between picking up a rigid body, where if I pick up a rigid body, I am now controlling the positioning of the rigid body. The logic in Extra Tools when you grab a static body is that we're not moving the static body, that's static. We're now moving the player according to hand movement. So when we go back to our wall here, and I'm actually going to do that in the world, because we can see, these little markers for text. At the bottom here, we can also see that we have some climbing handholds, and these probably need to be in better positions. And I actually want to make a nicer climbing wall at some point. But I made some different shaped objects that function as little climbing objects. On this one, I've left the grab hand on. If you actually look in that scene, we see that we have a left hand and right hand grab. So I should be able to go and show this one. Actually, I want to make that work differently at some point. But so I've not really done a really good job in positioning the fingers. I just roughly put them in. I'm actually sharing the 7-finger positioning over all these handholds, and really what we need here is finger position specific to this thing. But yeah, you can see it's a bit of a climbing wall inspired thing. So that's a red one, and no, I don't want to save you. Let's go out of view. So the purple one is, again, shaped slightly differently. They're just randomized shapes that are then cut, and they have a little hole with a screw inside of them. So it's just to make it look nice. It's not really that special. But yeah, these are all static bodies. So we can see that the root node is a static body, and that is what triggers our logic. Now, before I show that, and again, I really need to make something for this. Where is it? Why don't I see you? Like, oh, it's in the folder spectator here. No, that's the helper things. Oh, here he is. I'm just being blind. All I want to do right now is, and this is always a bit of a gamble, where it needs to go is I want to just move my camera a little bit more here. There we go. And if I've done that right, the camera should now be on the right side of this table. It will face me. And hopefully when I move over here, the camera will follow me, and you guys will actually be able to see what I'm doing. So let's give that a try. Alrighty. Oh, the controller's turned off. They went to sleep. Okay, there we go. All right, so the camera is there, so that should follow. I'm pretty damn close to it. Now, these first two are on the low side, so I can pick that one up. And you can see that I can now pull myself up on this one. And when I hold it with two hands, I can actually even turn a bit. Maybe I should actually switch the camera in a moment to first-person view. Should really have something internally. Now, one of the things that I did for pickup was that when you let go of one hand, there is this, the difference in orientation, because I can actually move my hand in order to orientate myself. And you can see this shakes a little bit because there's a bit of a a springy action there, and it's actually a little bit over the top. So that's something that I need to improve on. I can actually also climb down and push myself into the ground, and then when I let go, obviously the raycast thing allows me to get up. The other thing, I don't know if you can notice this in the camera, but I'm actually bouncing right now. There is an oscillation problem that I still need to solve in the raycast logic. So it's another thing that we need to start looking at. I think I need to put the camera a little bit higher because you guys are actually looking up at me at the moment. Anyway, I hope that actually came across well on the camera. But yeah, that is basically the logic that we are going for here. Let's actually make sure that I completely closed that. That wasn't right what I had in mind. So let's go and put you a little bit up for next round. So yeah, something that I still want to do is make sure that we can actually move the camera or position the camera while I'm running around. But for now, that's not in there. But yeah, the basics here for the climbing wall work. I'm pretty happy with it, actually. So I could obviously increase the height of this climbing wall and add some more, climbing things to it. Might actually do that at some point. Heck, maybe even make a whole climbing wall game, which would be pretty cool. But yeah, it works really well. Again, that little bounciness I need to get more fine-tuned. A lot of that logic is just inherited from the logic that I wrote specifically for grabbing rigid bodies, because there it was really drawing. I did that in the last stream, I think. We highlighted that and implemented that logic because, again, when you hold something with two hands, we're sort of taking this average between the position of the two hands and positioning our object there. So when you let go with one hand, the object sort of springs into place of where the hand that's still holding the object is. And we sort of made that a little smoother, but as a result, you get this bounciness that is really pronounced when you're climbing a wall. So a lot of that stuff is also tweakable. So yeah, there is some more improvement to do there. I'm actually also going to go and have a look at my red one. And let's actually go and not show this at all. So I think it is kind of nice to see the handholds in the editor like that. But at the same time, it can get kind of jarring to see hands floating around everywhere. All right. So that really, in a nutshell, is all the stuff that I've been working on. So yeah, I'm trying to think what else I can demo with that is interesting to see up front. I think a table is actually, where's my table? Why is that suddenly? Okay. So if I go to the table here. No, collision. Yeah, I left that in one. So let's have a look at what that does. So this is just to demonstrate that. So yeah, I hope that is quite visible. So if I go back to the table here, move you out of the way. So I can actually grab the table, and I can now move around when I've got the table grabbed. So yeah, that's pretty cool. So it's not just limited to too close to my computer. It's not just limited to the handholds. I really need to solve this bouncy thing. The whole point is that it's really easy to make things grabbable, and it really depends on what sort of game you're making or what you intend to make is how you set this up. This is, one of the big reasons why in my demo I've made most things in a separate layer so that you can't actually grab all the walls. But if that is something that you want to do in your game, then that is something that you could make use of. But by putting things in the right layer, you can selectively make things work. The other thing, of course, is that like the table, because we don't have hand positions, it finds the closest point on the table from where your hand currently is to grab it over there, and that is where you grab it, and it tries to you know, it does have a fixed hand grab orientation, so a fixed finger orientation. But yeah, it works well as a for what we use it for right now. And it's probably, there's probably a lot of things that we can improve with actually positioning fingers on the surface that you're trying to grab. However, like I said, you could make like a gorilla tag type movement with it by just grabbing any object and just dragging yourself along. That is all possible with this this approach. The way that I'm using it here, where only the grab points are grabbable, that's would allow you to make a game like The Climb, or you could do some parkour sort of thing where where you could climb up a wall or the side of a mountain or whatever, or a hill, and then climb over the ledge and stuff like that. And that's also one of the reasons why, for instance, that example of grabbing a table is really nice, because you can have things to the side of you where you can then lift yourself high enough so that you can actually get onto a platform or things like that. That's actually something that I wouldn't mind building as part of this. We might actually quickly do that. That would probably be a nice thing to have added in here. Yeah, why not? So, we're going to abuse a wall for that, believe it or not. Could probably just add a new wall in there, but I'm just gonna do it like that. I actually want to go and reset that. So in this case, let's see, where's the size here? So let's start. No, I actually want that 1.1 and this 1.1. So remember, walls are designed to be upright, and probably we're going to go for 2 meters. So let's make this 2 by 2. So because the walls are designed to be standing on the ground, our anchor point is actually at the bottom here. But because we're going to make this use of this as a platform, we're just going to go and do that. And we're going to go move that up. Let's put it up 2 meters like this. And this is actually where I really would have liked to have. There we go. So let's go and move that somewhere over here. Is that a nice place? Do we want it to have it more the sun? We also need to look at, okay, where is our camera going to come from? But yeah, we're going to want to be able to climb up on that. Yeah, that's good. So let's just call this platform. All right. Thirsty. So now we're going to have to make some sort of rail that we can climb up with. And for that, I'm going to use a CSG scape. So we're going to go CSG, not a box. We want a CSG polygon. There we go. All right. No, I want to do a path. Then we need to make a path. I'll do that in a minute. I'm going to want to put that not that far. So let's make that over here like that. That's probably good enough. All right. Cool. And then we need a different shape for this. That definitely needs to become a lot smaller. That is probably correct. We will see that in a minute. We're not joining it, so we don't care about any of those. Here we go. This is the one that I wanted to change. All right. The shame with this is that it doesn't immediately update when you change that. You can see that we've moved that over there now. Actually want to move that here. Oops. Okay, so that is there. Excuse me. Oh, I actually want to do it like this, I think. Yep. And then our second, so I'm hoping that that is vertex number 2, but if it's that one, then we obviously will move it differently. So let's make that like this and see what that does. Why did that not change? Because of that reason. Okay, so I've got that there now. Okay, and this one I want to make 0.1. Yep. And then the last one, we're going to make 0.1 this. So I'm not going to make it nice and round. I'm just going to make it like that. We'll cheat with that. We might actually make it slightly smaller, but we'll see. So now we need to create a path for this to actually make that a nice little archy thing. And I want to make that high enough. So this is the part that I always think is hard to do properly in Godot. Because what we really need for that is to look at it like this, but then we have everything. Now Z had this this PR that he has opened that it doesn't do the stupid thing of putting the camera all the way back, so I can now not see what I'm doing because this stupid wall is now in the way. So that's this wall over here that we're seeing that is preventing us from actually using that. If we would just have the camera in the right position, this would work. But no. Let's do something dumb like this and make it impossible to see what it is that we need to see. So now I need to go here and I need to hide these wall pieces. There we go. So that I can now go back to my path 3D. And I can now do that so that I can actually see it. What is this one? Which is that? This one's in my view as well. Go freaking away. Sorry, guys. I'm being very frustrated by this because it's such a dumb design choice and I do not understand. Who would be liking the fact that the camera is being put all the way here and no real way to, because I can zoom in, but it doesn't actually change the position of the camera. It just changes the field of view. So yeah, anyway, kind of problem averted. We can now see it correctly. So let's see how much it screws up with creating our points now. So I'm going to just start over here. We will tweak these values eventually. I want to go up. Then we're going to make an arch over here. We're going to go make an arch going down to here. And now I can go all the way down to the ground. That is fine. Again, like I said, we're going to tweak those values in the editor in a moment. But I do right now want to select, is it this one? No, it's this one. No, it's not the tilt handles. It's this one, control points. No. This is the other thing, which it's not easy to select the control points anymore. There we go. Okay, that's what I want. All right. I want to do the same with this one. Basically, what I want to attempt is to make that nicely curved. That is good enough for me. All right. So now we should be able to say, assign that path. And it's not working. All right. Because it's also not in the right spot. It's now centered on there instead of... God, this interface is so frustrating. Points. So I think we just zero out all these. Is that everything? I think so. Okay, so now that's all there. It also means that we can now nicely start moving this properly. So that one, I want to get over there. Interesting that that's the Z coordinates. And that the Y is actually how far it's moved. So half a meter from there is about good enough, I think. And this one should also be half a meter by half a meter up. So we're going to go and make that one. Which one's this? Oh, that's the in and out. Oh, sorry. I can't undo that. Okay, let's keep that the way that it is. And this one, I want to get on 1 meter so that that's a nice arch. Actually, let's make that 25. Let's make that 25. That one of those doesn't actually matter, but all right. All right. So this one. There we go. That will be nice as well. And then 25 by 25. And then this one can nicely be so 2 meters above the ground. So that brings it back to exactly on ground level. So that should now have our path correctly. But now, why is it not extruding that path? Is that because we go path follow? Is it inside out? Maybe. Flip faces? No. Because it's supposed to extrude that shape along that path. What am I missing? What am I doing wrong? I've set it to the right path. Interval distance, that's great. So I've said that every 10 centimeters there should be a thingy. That shouldn't matter because, it does help, but I don't know why that matters because the Path 3D and the Polygon 3D are at the same location. But we can see that we're inside out now. So I flip that back. There we go. I also want to have smooth faces, so that kind of looks rounder. It is way too thick, but it is making our arch, which is cool. So let's make it a little less thick. Let's make that half the size of what it is right now. And maybe I should put some more vertices in just to make it nice and more rounded. But I want to keep it nice and simple. So there we go. Now, the nice thing about using CSG is that we can just turn on use collision, and that turns this into a static body in collision layer 1. Very cool. So with that, we can actually, let's call that railing, whatever. Let's go and save this. I really need to organize that better at some point. So there we go. We've got that now as a subscene, which also means that we can give this a material, which would be nice. I'm just going to keep it standard material for now. I just want that to be a nice metallic material. So we're just going to crank up the metallicness of this. Oh, look at that. That is why the X and Y is different, because that's right. We flipped our platform around. That's kind of cool. I don't mind. That's fine. Let's turn the roughness down a bit. Just want to make it, the illusion that it's shiny. So there we go. That is good enough. And now we can go and call that railing 01. We can duplicate that. And we can move that in. Now, one other thing I'm thinking about. Too late now. I was thinking maybe I should have given that a Node 3D as a base because I don't really want these things to be editable. Maybe I should. Can I? Can I quickly change that? So if I go and delete that, all right, I'm going to go and make local. So that's now no longer linked to the subscene. Very cool. That means I can now do a Node 3D here. Move that over there. Move that over there. We're going to call this back to CSG Polygon 3D. Cool. We're going to make that railing. And now let's first save that, or else it's going to complain. Save branch as scene. And let's override our railing scene. There we go. All right. The reason I've done that is that that is now a Node 3D, so I can't actually edit that stuff, which means that this is cleaner. This is nitpicking. This is really, doesn't matter that much. Yeah, so that's railing 2. And then that one, just going to move over there. So with that, we have this railing that we can pull ourselves up with. Right. And of course, I closed our spectator view again. I'm so used to just closing that because I want to move this camera a bit higher. There we go. That's good enough. Yeah, hopefully that'll not look too weird, or else I need to switch it off to first person view, but we will see. Where are my controllers? Okie dokie, here we go. 2 hands, yeah. So where is, the camera's all the way up there. Oh, this is going to be trippy. I hope that was okay. All right, I put them a little bit too far apart. I probably need to put them closer, but the idea now is, that's not good. What did I do? Oh, because CSG polygon cannot be changed to a physics body 3D. Bugger. Right. So even though it is a collision shape, this is where CSG is such a pain in the butt. All right, how are we going to do this? Can I turn this into a proper static body? CSG. Yeah, we can bake a mesh instant collision shape. Okay, so we can do it that way. So let's do it that way. So we're going to turn off use collisions. We're not going to use it as a collision shape itself, which also means that we can change this to a static body. There we go. And now we're going to say bake collision shape. And there is our collision shape. So now we're using that collision shape instead of that, which means that we're using this as our static body, which means that in our world, these are now static bodies. Very good. And let's move them a little bit closer. Let's see if that now allows us to climb. Now, I suddenly realized I might have made my player's collision shape too big, and I might now have put these too close to each other. But I can now pick this up, and I can climb up. And here we can see that the logic for doing that. Oh, and I fell down. But yeah, no, I can't push myself in between these bars. I've made them too close to each other. Oh, look at that. My hand's stuck inside. That's interesting. That's another thing to fix. I thought we fixed that already. That's something that I worked on, but obviously I've missed out something. It's supposed to make a collision exception between those and leave that collision exception in place until my hand moves off. So obviously that isn't completely working yet. Anyway, let's move this a little bit out of the way and try again. And again, building these sort of things is good experimentation to test sort of the limits of the logic and see where we've made mistakes. And obviously we have made a few mistakes, so I do need to resolve those. So the other thing that I wanted to have a look at is my player itself. So my player has a raycast body, and the torso radius was 0.3, and that was my problem, because my radius of my character is 0.3 around, which means that I didn't fit between the rails. I couldn't push myself over. So let's see if that is correct now. All right, so I can now grab that. And I guess the thing that I need to change is when I grab them with two hands, I'm immediately twisting my body based on, well, I think there's actually a bug there, because it's not supposed to twist it that much. So I'm not quite sure why it thinks that it needs to twist. So there's definitely something not right there. However, I can now fully pull myself onto the platform, and I'm moving up on the platform. Yay. So in principle, this fully works, and I can drop down and I don't have fall damage, which is really good. So obviously a few things to improve and to make better. Oh, come on. I'm a little afraid of hitting my keyboard. I think I'm just turning it the wrong way around, because it's supposed to bring our hands closer, and it's not doing that. So there's definitely a mistake that I've made there that I need to look at fixing. Yeah, my computer is in the way. Oh, of course, if I don't grab it properly, then I fall down. I'll get there. Oh. Now the other thing is, because I don't know if you guys can see this, and actually before I continue, just want to change the spectator camera to the camera that you guys can see what I'm seeing. All right, way too close now. The thing that I wanted to show is, obviously when I grab this, it's just grabbing the pole at its closest position. It's making a fists thing, which is not accurate to that, but yeah, it's just that at this point, I'm twisting the wrong way, and I need to figure out why that is. It's obviously a mistake that I'm making on deciding how much I need to turn. Figure out why. But I can grab this nicely, grab it until I am hopefully on here, and then yay, I'm on the platform. And that is the most important thing, because in Extra Tools 1, oh, where's my, oh yeah, that's because I'm using the spectator camera now. In Extra Tools 1, we had logic that when you were climbing up a wall, that we would actually make the player's collision shape very small, so that you could sort of push yourself over a ledge, and then when you let go, you would kind of like stand up. Now here, oops, I didn't mean to fall down. Here I've now made it so that you can actually pull yourself up far enough that the player body is now above the platform, and I can drag myself onto the platform, and then when I let go, I'm obviously standing up, which is much better, much more natural. Now we don't have an actual visualization of our body, so it is a little bit hard to see when I've actually gone over, but you know, it does work. Now the other thing which we might, just for completeness, do here is put some bars to actually make this seem like a proper climbing thing. So let's complete it with that. And then the whole point obviously is that this, you know, it all communicates what is possible here with the mechanics, but also, you know, helps us find the problems that we have and that we still need to solve. All right, so we have our two railings. Let's create, we're going to do that as a static body as well. Call that a rung, not a rund. Rung. This one needs to be, it's too much. Over here. Cool. That now needs a cylinder of some kind. Cool. We know that that cylinder needs to be 1 high and that wide and oh, perfect. Okay, almost good. So we're actually slightly too wide. That's because these are 0.4 apart, not 0.5. So this should actually be 0.8. Okay, cool. So we just made that the same, the same rectangular shape as the rest, but then using the fact that it's smooth to sort of smooth it out, which also means that I want to go in here and I want to go in here and I want to find my material. Excuse me. Actually, let's have a look at materials that we've got defined here. Those are, we can use the metal screw material if we want. So let's do that. Let's be, nope, that's the wrong folder. Materials. So this is a material that comes from our imported scene. We might as well reuse that. And then we can use that on this one as well. So load. Use that same color so that we just have the same materials for both. Cool. And then obviously collision shape here. And that needs to be a cylinder shape. And then we have to need the same rotation, which is -90. And then the same sizing information. So the radius was 0.5 and that was 0.8. There we go. So now we have a rung. Let's go and save that. And again, at some point, I need to clean this up a little bit better. Let's rename that 0.1, and then this one needs to go down a bit, not that much. So let's say let's do it little. That looks nice. 6. Nine. 1, 2. And I guess this is just this is mostly just scene dressing, nothing more. Let's do one more. Yeah, that looks nice. Hey, Wang Dong. Yeah, I hope this is informative. Okay, so let's go and go here. All right, and now what I want to do is go right to that so you guys can see what I can see. So yeah, so now we have a nice little thingy here. Again, I probably should be, maybe these rungs I shouldn't do 4 just to make it look a little bit rounder, but hey, it's just for testing. Oh. So yeah, I can pick those up too, so I can actually climb on the rungs as well. And this is where we can really clearly see that I've made a mistake there. I need to fix that. I might do that next. But I can nicely climb up and yay, I'm on the platform again. So that works way better. I like it. Yeah, I'll clean up the railing at some point to make it a nice round shape. But for now, it's good enough just to experiment. Nope. What am I doing? There we go. All right. Cool. And just, since I didn't do this first person, just to show, like, and again, same thing. I'm doing something wrong with the way this is turning. I wonder why it's suddenly turning so much here. It's obviously an axis thingy there. But anyway, yeah. Hey, it's all new logic. There's bound to be some little things that need to be improved. But yeah, in essence, this is nice and easy to see how easy it actually is to set that up. The other thing here, obviously, let's just go for 8 so that it actually looks a little bit more round. And let's go and reproduce that here as well. So when we are looking at a polygon here, I actually want to turn that into 8. There we go. So this is going to be fun. I wish that it's actually, we probably can. I just need to make more room. Can't make more room. Why can I not make more room? I want to make more room. Manage. We'll manage. Should be like little up-down thingies here. So this one. Oh, that is way too sensitive. Okay, so cool. So we're going from 0 minus 0 to there. So this, let's go and assume that that is going to be 0 to 0, 3. All right, so again, I need to click back and forth to see where that ends up. We might move it out a little bit more. Yeah, maybe that should be 3, 5, 3, 5. Again, reselect. Yeah, that looks decent. Okay, cool. So now we need this one. Oh man, this is hard to see what I'm doing. I think so. Yeah, that's actually in between there. So here, so the x should still be 0.035. But now the y needs to have that in the positive. Okay. Cool. So now that arch is nice. We need to do that one. Problem is this, the 0 in here makes it hard to see where the one is that I need to move up. So this needs to go, oh, not so far. There we go. All righty. So this one, I think needs to be like this. Perfect. And then this one is like this. All right. So now we have a nice circle looking thing, which means that this looks a little bit less blocky. That does mean that we need to recreate our collision shape. There we go. Yeah, that's always a problem, Wangtang, is when you're used to something, you are fast at it, you are fluent in it, and then when you pick up something new, you have to learn it all again. There are obviously a lot of things that Unity does that Godot does in a similar way. So once you wrap around the small differences, it should be pretty quick to pick a lot of things up. But there are also many things that Unity does very differently than Godot does, and you really need to, unlearn and relearn some tricks. And then last but not least, if you want to do VR stuff in Godot, there is still a lot of stuff that you will need to build. ExtraTools 1 is a really good starting point, but it is getting a little on the old side. There are a number of things we do way better nowadays than, but where we have a lot of technical debt in ExtraTools 1. What you're looking at right now is the spiritual successor to ExtraTools 1, currently called ExtraTools 2. But I'm thinking of renaming it simply because there's a naming confusion there, because XtraTools 1 is actually on version 4 right now. So going back to version 2 will probably confuse a lot of people. So we might rename the toolkit just to make clear that this is a complete rewrite. But as you can see from the demonstrations that I'm giving, there are still a lot of rough edges to this toolkit, and I'm currently really focusing on getting the functionality in here that I want. And once all the functionality is there, I am going to start back to sort of optimize things and improve the way things work. But I'm really trying to focus more on getting the features in there than getting the features perfect. So yeah, there will probably be a lot of rough edges to this for a little while until I've got enough stuff in there that I can say like, okay, now I'm happy. That also reminds me, I need to unhide all those things that I had hid before. Here we go, because we now no longer need them hidden. So perfect, that's all back. Cool. Alrighty. Yeah, XtraTools 1 is still pretty much what it is and has been. There's been a bunch of fixes and small improvements, especially around the grabbing logic. I did a bunch of work not long ago, and the fact that we are now using grip poses instead of aim poses, which means that controller positions are more accurate than they were before, especially with recent changes in some of the runtimes that made positioning a problem. And you know, it's very full featured, so it is still, you know, it is a good toolkit to just get started with. It's just, you know, there are some things that are getting a bit old. Yeah, collisions and raycasting is actually a lot of it works really well, but you need to understand a little bit about how things work in Godot, and what are the performance approaches to doing stuff like raycasting. So a lot of people coming back from Unity are used to doing raycasting in code, and even in XtraTools there are a number of raycasts that I purely do in code, because singular raycasts in code are fine, but there is actually a raycast node. So I'll just grab one. Oops. Just to illustrate that. So let's just move that out of the way so we can actually see this thing. So you can see that there's this big, what you call it, blue line being drawn down. That's actually the raycast that we're performing with this object. And this raycast, the nice thing about this raycast is that it's part of the physics cycle that it gets executed. So first of all, you can obviously configure how it works and what it needs to do. But it will also just have an immediate state that you have available. And it's more efficient as a result than doing it all in code. So this is something that a lot of people sort of get stuck in who are used to doing things in Unity with code, is that suddenly they do 100 raycasts and they wonder like, why is my application working so badly? While if you do a whole bunch of these raycast objects, it does it much more efficiently, and yeah, you immediately get a lot of states back. But there are limits to this. So I believe in our raycast body here, if I go to the script there, I'm actually using a raycast query. That's just a capsule shape. Where am I doing this? Motion. Yeah, so here I'm actually doing a raycast directly on the physics server. So I'm creating a raycast query, and I really should be caching that one instead of creating it every time. Hoping that actually gets, yeah, that should automatically free itself. And then I'm using the physics state to directly execute. So there's an intersect ray function here that I can execute. But this is the raycast itself is fine, but because it's now looping in code, it actually has some overhead. So yeah, it's just something to be aware of. But it's those sort of things. But they are, otherwise they work the same, especially when you use Jolt, which is now the default physics engine in Godot. It's, the raycasts themselves execute very quickly. It's purely the way that data is communicated that has some overhead in this approach. But for this situation where I'm doing a single raycast per frame, it's negligible. But if you would do 100 raycasts like this, it's better to use the raycast object. Yeah, I will remove that. Cool. Yeah, and I really like the visual indication that the raycast does. It does make it a lot easier to figure out what's going on. So it's pretty cool. Okie dokie. No, by the way, that for this demo, I'm using all sorts of like primitive shapes, so it doesn't look fancy. I'm not using properly properly styled assets. It's just to keep things simple, but yeah, works well. Okay, so we have picking up rigid bodies. We have positioning the hands and the fingers if we want to have control over that. We have climbing up static bodies, both little climbing utensils and now a nice little railing thing. And we have a bunch of things that still needs to be improved and fixed, but all in due time. The next thing that I want to do around picking up is actually interacting with objects. And again, I want to sort of see how far can we go with the logic that we have at hand. But there are some problems here that we need to solve. And again, we're going to start with just creating everything purely with standard objects. And then we're going to go and see if we can do and make that work in a way that makes sense. So the next thing that I want to do is actually make a door. All right. So we have a table here. Cool. Let's go and add a door in this thing. All right. So we've got a bunch of walls. I'm just cleaning up a little bit by closing stuff so that we can actually see what's going on. And again, same deal. We're gonna create a door from primitive shapes. It's not gonna be pretty, but it's gonna be functional. And in this case, I am gonna start with just a normal node 3 as a root where we can place our door. We're eventually gonna move our door somewhere more sensible. That actually reminds me that I'm probably gonna want to move that back to a more sensible height because we're not going to climb up anymore. All right, so that's going to point out. We might actually put the door over here eventually. But let's go and start with just getting the basic objects that we need. So let's just start with our door itself. I know that looks weird, but don't worry. I'm going to be renaming things in a bit. I just want to get the shapes in place. So we're obviously going to do a box mesh here. We're going to make that a thin door. We're going to make our door 2 meters high, 1 meters wide, which also means that we want this to be 1 meter off the ground. There we go. Cool. And then I always want to have a little frame around the door just for visibility. So let's create that. So that's going to be another box mesh. That's going to be slightly higher because it needs to top out. That's going to be small, small. Cool. So that means that that's going to be 0.05 off the ground. And that needs to be 0.5 meter and a little bit to there. Oops. Yep. It actually looks too high. Is that correct? No, that is correct. And I'm also wondering, should I make the door slightly thinner? Yeah, I'm going to make the door slightly thinner. Just to make the difference between the frame and the door more apparent. Cool. So that's going to be 0, 1. And then we need a door on the frame bit on the other side. And now we need something at the top. Mesh instance, and that's going to be called frame top. Right, that's good. Then I click. That's going to be another box mesh. In this case, that's going to be 1.1 and 1.1. I think it's going to be like this. That'll be good because it's going to stick slightly into that. Actually, no, I want that to be exactly 1. All right, and that is then going to be, there we go, perfect. That's going to be up there. So now the question is our door, should our frame be slightly outside of the door? Should we make a gap, or is that overkill? I don't know. Anyway, let's go and save this door as a scene in our components folder. And then we can move our door into position. Let's go and put you over there. Put you over there like that. Okay, let's go. Turn that off. I want the door to be against our climbing wall. There we go. Cool. All right, and with that all done, let's also go and assign some materials to this. So let's start here. Okay, what am I using? I think it was this one. Yep. Obviously we need our checkered thing. There we go. And let's give you a color. What is a nice frame color? A sort of brownish is nice. Cool. And we want to scale one of the UVs. Is it this one? No, we want to scale that one like this. That is good enough for me. Yay. Cool. All right. Now, the reason why it's coloring both, by the way, is because I'm setting the material on the mesh. And because we duplicated that, both these are using the same mesh. So this is not a different mesh, and therefore the same material. That's an efficient way to use our resources. While our frame on the top here is actually a new mesh because it's a different size. So one of the things that we can now do is we can actually go and copy this material. And we can go and paste that over here. But I'm going to paste it as unique. So if I paste it, that means that the material is shared between all 3 frames. And that means that if I'm going to change the properties for the material on my top frame, that's going to be a problem. But by pasting it as unique, that's going to go good. Now, the other thing that it wants to know is, what do I want to make unique? Do I want to make the shader unique? If that happens, it's going to recompile the shader for this material, even though it's the same shader as used for the other ones, which is why this one is disabled by default. Here it's going to say, do I want to make the texture unique? No, I do not want to make the texture unique because I'm using the same texture for all 3. I want to use the same texture resource. I don't want it to create a copy of that resource. But I do want the shader material to be unique so that I can change the properties of the shader material. But it's still reusing the same shader and the same texture. And these two are really important in this case because as much as I can reuse the shaders, which it really should always do anyway because it's linked to the shader file. That means that that shader is only compiled once and it's reused for all these materials, which is efficient. And the same thing with the texture. I only want to load the texture once, and I want to use that texture all over the place. I don't want to have duplicates of that resource with all the overhead there. But now I've got my same material here. We can see that, with my UV, that is really screwing up now. I can't really do anything about the top. This is not a nice, what's it called? I always forget the name of this. It's not a nice world planner UV thing. So, yeah, it is what it is there. Anyway, I should now be able to change this without that affecting the other ones. So we can go and put that back to 1. And maybe this one needs to become 2. Yeah, that looks good enough. Again, we're not going for perfection here. We're just going for something that makes it look half decent. Cool. Now I'm going to do the same thing for the door. And again, I'm going to go and just paste my material as unique. Reuse that. So we start off with a material that is the same as the outside. But in this case, I want to change the color. I actually want the door color to be, I want it darker, lighter, maybe a slightly different hue. No, what is nice for the door here? I just want it to be looking a bit different. Oh, can I? That's still too much the same. I don't know. I don't know what is nice here. As long as it's a different color from the rest. All right, cool. So now we want to make it possible for this door to open and close. All right. And for that, I'm going to actually change the door to a rigid body. Cool. Now, do I care whether that is nicely centered or not? Or do I want that to be nicely in the middle? I think I will want that in the middle. All right, so I'm just going to rename that to our door body 3D. All right, cool. All right. Now, the thing is, I actually don't want the user to be able to grab that door. And I'm going to leave that alone for now, because I first want to show why I actually don't want the player to be able to grab that door. But we need to do a little bit more with the door to actually make it work. Because right now, if we would run it, the door would just fall down, or might stay right up until I touch it, and then it'll just fall to the floor, which will open the door, but it's not actually what we want for opening a door. So the other thing that we now need to do is we want to create a hinge joint. There we go. I'm actually going to put that one right before here. And I want to move this over here, because we're going to hinge it on that point. Now, we might need to rotate this hinge point. We will see in a minute. But we want to go and hinge on that. Now, I do also want that to be somewhere over there. So we're going to go and make that door open that way. And I'm just going to go and do that like that. Okay, cool. Now, with the hinge, we have 2 sides to the hinge, because we're hinging between 2 objects. So we also need an object to hinge. Okay. I'm also going to want to probably put that hinge up so that it's in line with the door. But in order for that hinge to work, we're also going to add a static body here. And again, same thing. We're going to put that over there. Look. So maybe that needs to be 5.5 like that. So that puts it nicely in the middle of there. That's good. All right, so now for a hinge, we can say it starts with a static body and it ends with the door. Now we've created a hinge between the static body and this door. Now we have to start creating some collision shapes in place. We'll deal with that in a sec. The other thing is we can see that the hinge joint is now rotating like this. It's not what we want. We actually want that to be like this. So I'm actually going to do positive 90, I think. We might need to put that the other way around. Why does it not redraw that? It's interesting. Why does that not? Let's reset that back to 0 because I was expecting that to change our gizmo. Oh, because I rotated the wrong one. That's not going to work, is it? There we go. Let's rotate that 90 degrees. All right, cool. So now we want to make sure that the amount of turn that we have is limited. So we're going to have an angular limit. Right now it's going from 90 to minus 90. And this is the problem that I always wonder. Like, how can we really see what that's doing? Because I was expecting these lines to change. It doesn't really seem to do that. Also not with this one. So let's just see how much it turns and whether it turns in a way that makes sense. Because it might not. Oh, we also need to enable that. That's why. Okay. So let's see. That is how much? Why is that? So that looks like what I want, but I want to actually be, let's actually do it like this. So this is what I want, is that it opens that much, but I don't know why it has this second thing that it shows. Because I'm expecting this to now be like, okay, we go to upper 90, that's cool. And this is how much we limit that. It's also cool. But again, I've got no idea why it also draws that, what that actually means. We'll find out soon enough. So this should limit our hinge joint from, hey, the door is closed to the door is opened 90 degrees. All right, cool. So next thing, this needs to have a collision shape. Actually, I don't want to do it like that because that creates a tripolar shape. Actually, it didn't. Yeah, we did. Primitive. Does that create the right? Yeah, it does. That's something that Z added. So if the mesh is created based on one of the primitive shapes that is supported by the physics engine, you actually have the ability to create a box mesh out of that. So we're going to do the same this time on frame 2. So create using the primitive. So there we go. But we're going to move that onto the static body. Now the static body collision shape doesn't really matter. I just need a collision. Even if I made a tiny little bowl there, it would still work. I just need a collision shape for this to be registered in the physics engine so that our hinge joint works. That's all we need that. So, but duplicating the frame is fine. And we could even say like, hey, let's go and call that collision frame 2. Oops. And we could even go as far as saying collision frame 1, which would now be almost good over there. And we could even do one for the top. Oh, why not? Let's just be complete. Create. And we'll add that over here. So one thing that is also important here is you can add multiple collision shapes to a single physics body to kind of create a complex collision shape for that physics body. So again, the collision shape itself isn't really important here. We're even going to I'm only going to put that one in layer 2 because I do not want to be able to grab that one. But for my door, I'm going to leave that in collision layer 1 for now. Probably need to turn on a few more on the mask, but that's fine. So in theory, we should be able to push the door open and closed right now. And we can probably grab the door and manipulate it there, but when we grab the door, we can actually manipulate the door in a way that is really, really bad. And we'll demonstrate that in a minute. So in the world, there's our door. Should be wide enough for us to get through. Perfect. I'm happy about that. So now the other thing which is important is this exclude nodes from collision. And this means that our door is not going to collide with our frame. And that's kind of important that we make that collision exception, because with this well fitting a door, that would mean that we're actually going to get stuck in the door frame when we try to open it. If the door frame, if we want to actually have it interact with the door, let's say that the door frame is also limiting the movement of the door, we might want to untick that, but then we need to make sure that the size of this door supports that, and we're not going to actually have the door colliding with the frame as we try to open it. But right now we leave that on. That means that that isn't going to get in the way. All right, so with that all in place, let's go and see if this actually works. And again, I am expecting some problems. Go. Alrighty. Cool. Come on, second controller. Before we do that, I am going to go back to stabilize camera. There we go, so you guys can see what I can see. My door is over there. It's nicely in shadow. Hooray, hooray. But I should be able to push the door. And actually, we can already see our problem, even with pushing, is our hinge joint is actually not limiting that. Now, obviously, we've got our hinge in such a way that that we can only open in the other direction. So I should be able to just move around. And if I push it on this side, I can actually open it. So that bit works. We can see that it slowly falls back closed. It's hinging a bit weird, though. Not sure why it's hinging like that. But yeah, the big problem here is I can close it like that, but if I try and push it, I can overpower it. Same thing with, I can grab it, I can actually, oh, that goes really bad, because now I'm just applying forces to this door that it just doesn't know what to do with. So, oh, and I'm getting way too close to the door. But yeah, it just doesn't know what to do with this, because it's trying to move this door to where I'm holding it. And it's also even got the grab distance the wrong way around. And it's really panicking. Oh, boom. So yeah, I can manipulate the door when it's open in a way that makes sense. But yeah, I can overpower the position of my PC in a way. So again, like you guys can see, is I can actually move it all the way off of his hinge. It's not happy with that. So that is one of the reasons why I don't actually want to make the door grabbable. We're going to do that differently, but we also need to look at, okay, how can we prevent the door from going crazy when we push it like that? So one of the things that I definitely want to do is I want to put my door in layer 2. I do actually want to enable both these in case I have something in layer 2 that, or in layer 1 or in layer 2 that interacts with the door. But at least that will prevent me from grabbing it. It doesn't prevent me from actually pushing through the hinge. Now with that, I don't know if there's any properties here that could prevent that. The speed with which two bodies get pulled together when they move in different directions. So is this something that we can really move up? Oh, look at that. That's not even supported by Jolt. Yay. Is that the same with this? That's also not supported by Jolt. This is so annoying. None of these we can tweak in Jolt. Which, by the way, does not mean that Jolt doesn't support that. It means that the way that physics is set up in Godot, which is based on the original Godot physics implementation, isn't compatible with the way that Jolt does things. And instead of us adding properties to this for the Jolt way of doing things so that we can configure this from working properly, we've simply said, screw you. We don't do that, which is, again, one of those things that I am personally not a fan of. I'm a strong believer that we should allow to do this right. So right now, I do not know what we can do. What we can do about that. What we can do to stop that from happening. All right. So, so the pushing the door and pushing the door out of the frame, I'm going to leave that problem alone. That is something for later to fix. That might actually even be something that I will raise on the physics, the fixes channel, and see if someone can actually suggest what we should do there. One of the things that I am thinking about is I have this logic that when you push against a door or any object, is that we transfer a force to that door or to that thing. Maybe I'll put some limits on that, or one of the things that we have, and I'm just going to add that in here just to show. What is that called again? Here we go. So we have this extra to rigid body behavior that defines, okay, how does this actually work? So we do have a grab a static body here, which is not what we want to do right now. We're just not making it possible to grab this at all. And that's something we need to probably do something more with. But we might be able to do something like, okay, have additional logic here. Where we say, okay, if we push against this, what are our limits? It's probably something that we can implement there at some point. But now I'm going to leave that problem alone. What I right now want to do is make sure that we can actually open this door and close this door by grabbing a handle. The other thing that I want to do, which we're going to... Yeah, the other thing that I'm going to do... do I want to start with that? No, I don't want to start with that. But just to sort of repair this already. Where is it? Here. We are going to end up freezing the door. So we can do a freeze. This means that we can actually not push open or close the door. And it will actually disable the functionality of the hinge joint. It basically turns this door into a static object. But it simulates that our door right now is locked/closed. So the idea is to create a handle that I can grab, and only when we grab the handle, then we unfreeze the door, and we leave the door unfrozen until it is closed again. So only when the door is closed and we're not having the handle grabbed, we're going to allow the user to manipulate the door. So, but I think that is something for the end, and if we have enough time to do that. For now, I just want to work on the handle and make sure that we have a handle that we can grab. Now, that's the other thing that I'm sort of thinking about right now. How can we best do that? I'm even sort of wondering, should I actually make the door grabbable? It's a good one. Because the other problem that I have is when I grab something that is frozen, I am treating it like a static body. And in this case, I want to unfreeze it as I grab it. Because the thing that I'm starting to think about is one of the things that I've done different here. If we go, let's actually go and close this now because we don't need these anymore. So when I look at my pickup logic, one of the things that I did, where is my physics thing? Yeah. Is I've added that's the pickup logic. That's not what I wanted. So that is just to grab a static body. So what more do I do with that? So here is the overall is frozen. Here's if it's static body. Just make it false when we drop it. Right. So if I have a custom handler, so that's the thing that I was thinking about. If I have a custom handler, then I do my own logic and I can actually ignore the grab a static body. So I can make it so when I grab the door, then I disable the freeze. Yeah, that would work. Ha! So I can use my XR custom pickup handle to make this do what it needs to do. And it also means that, okay, that's actually really cool because I'm thinking about how I used to solve this in XRTools 1, but I actually can solve this the way that I want to do in XRTools 2 without too much craziness. We're going to put this back in layer 1, and I actually want to leave that on the default as well. So now I can grab the door, but we're going to create our own logic for how we can grab the door. What I really want to do is limit where we grab the door to the door handle. And that's another thing that I actually haven't thought through, because right now the collision shape of the door allows me to detect that my hand is close to the door and I should be able to grab it. There isn't any logic on our grab points to say, hey, I can grab this grab point, but my hand needs to be a certain distance to the grab point. And that should eventually be part of the logic of whether we can grab the door, yes or no. I'm not going to worry too much about that right now. I'm going to make the logic that I want work first, and then we figure that out. All right. So let's even just make it work first with that we can grab it anywhere on the door and then worry about the door handle later. Same with the freeze. We'll worry about the freeze later. Let's first get the basic logic working. So for that, I am going to create that in components. That's great. So we're going to create a bit of code on our door body. And the code that we want to do is we want to go, and I'm just copying this so that we have what we start with. And then the way this works is this: if this returns true, that means that we've handled the logic. So where's our door logic here? So this is one place, this, I know that people are wanting it and complaining about it. They really want to have traits. So we're really talking about a trait here. So that is that. That is just a delta controller target. I think that's a transform. That is a transfer operator. Because of course the problem that we have with something like this is that if we change this API on the pickup logic, all of a sudden we break things. So this actually is not. Oh yeah, that's a bull. I did do it right. Okay. So the fact that this now exists on our XRTool pickup, we are checking whether we have a custom pickup handler. But what we're not checking here is whether the custom pickup handler has the right parameters. So we're going to assume when we call it that these parameters are valid. That's something that you normally would enforce with a trait. But Godot currently doesn't have trait support, so we are doing it by convention. Duck typing allows us to do this by convention, which is really cool. But yeah, there is a possibility that if I change the pickup logic so that the properties here or the parameters here no longer apply, that we end up breaking code. But for now, that is fine. So with our custom pickup handler like this, and not implementing any code, that should mean, and I want to test this, it should mean that we can now pick up our door or grab our door, but nothing should happen at that point. Controllers have got to sleep again. And I want to make this again that you guys can see what I can see. I should really make that default at this point. All right. So if we go to the door, okay, there we go. We still have the problem that we can just push it in. That's not solved, but I should be able to grab it now. And as you can see, nothing happens as I move my hand. So we've got my little ghost hand so that we can see where our hand actually is. But I have grabbed the door at this point in time, which is really cool. So what I want to do right now is I actually want to ignore if the hand is up or down or left or right. I purely want to look at how far away my hand is from its original position. All right, cool. So we first need to see what is our original position, and we need to see how far away we are. Let's go see if we can make that work. What are you doing, cat? I heard you, but I don't see you. My cat was making noise. All right. So the values that we are getting here, let's double check what those mean again, because I can't remember that off the top of my head. It's been a while since I wrote that. I believe, yeah, the controller target is where our controller is. And our controller target with the grab offset gives us the actual offset based on where our grab point is. What we're missing here is the actual grab point on our pickup. So Actually, that is interesting because I think our grab offset let's visualize that because I just can't remember off the top of my head where these are. The controller target I do know. That is exactly where our controller is currently positioned. But then this one, I wonder if that is the the offset between where my controller was when I grabbed the thing and the center point, which in this case would help us, or excuse me, by the way, or if that is something else. So let's have a look at where that is by visualizing that. The way we're going to visualize that is we're going to add an axis scene here. So there we go. We see our axis scene here. That is just showing our axes. That's great. And what we're just going to do in our script here is axes global transform. So obviously we have some movement possibility. So maybe I should just do axes dot top level true, so that we purely position it in global space. Yeah, that'll be fine for now. Okay. And let's go back to stabilize camera. On. Oh, our hand was flying around. I haven't been gotten that to tracking yet. So there's our axis right now. But what I want to do is I want to grab you over here. So, all right, that's actually really cool, because I think that is now showing us this in relation to the center of our door, which is great, because now we can, from the center of our door, we can figure out right, that's the other thing I think that I need to do. Yeah, I think in order for our door to work correctly, we are actually going to go and we're going to make our center actually to the left here. So that means we want this to be minus 0.5. That's not what I thought. First of all, only half of what I need to do was there. Okay, so that's now nicely on there as well. Okay. So there's a little bit of an angle there, which is really interesting. And now we can go and move this in the opposite direction. I do the same mistake again. 0.5. There we go. And I do the same thing here. Minus 0.5. There we go. So our door is nicely there, but the center of our door is now over there. Cool. Sweet. So now we have two things that we could do. No, it doesn't really matter, because our positioning is what it is. All right, cool. So what I now want to do is this global target. We are going to adjust that to be local. So let's actually move that over here. Say var local target equals global transform dot inverse times global target. Cool. And now we're going to do this like this. So in theory, that shouldn't change a thing, except that we now have that same value in local space. Cool. Alrighty. Oh, that's, I need to change this default. There we go. Maybe I should make the camera in a better position anyway. So, oh, that's interesting. Oh yeah, because we're, okay, so we still can't do that. Oh, we see that now the door slowly opens, which is cool. Oh, we can go. Oop. That's cool. Let's go and close you. Oh, my computer's in the way. All right. So now when I grab this, we can see that our target there is still in the right position. But the further I move that, the better. Now I have a feeling that we've already made. Huh. I wonder why. Okay, it does keep moving. All right, that's cool. All right, so step one is done. So now what we want is, now that we have that in the local space, all that we care about right now is the position. All right, cool. So this is going to be local target dot origin. However, we're going to go and multiply that with a vector. And we just need to find out which vector. So I would say that Z was probably the right answer. Cool. That means I actually want to get rid of you. Instead, I now want to have a X to the vector. Cool. So, all right. So at a location in a certain direction. So unfortunately, this is again in global space or not. Oh no, it's in local because I'm doing the local transform. All right. That's cool. Yeah, sweet. So with that, we can now say vector dot, what was it? Place vector. Oops. Place vector is going to be local position vector 3 0 0 0. All right. So now we should see a nice vector pointing outward of the door towards where we are. Just looking underneath my thing. So there we go. Okay. So we can see that little vector pointer there. That's the one that we're manipulating right now. So when I grab this, we can see that. Oh, that's weird. That's not the way that it's supposed to do. Why is it suddenly so slow? Are we getting, ooh, we're getting a little bunch of errors here. Target vector can't be 0. Did I just put those the wrong way around? Is that it? I did, didn't I? Yep, I did. Oops. They need to be the other way around. Yay. All right, let's try that again. And before we do, let's go back to our spectator scene. How do I define the default camera again? Yeah, so how do I default? Camera selection drop down. On camera selection, but not selected. Oh, selected is 1. Okay, that should default it. Let's see if we do that right now. All right, so I think the spectator cam is now on by default. So let's go back here. Oops. Come on, a little closer. So now when I grab this door, I see nothing. Is that because it's... Okay, so when the body moves into the door, we also push the door open, and it's not happy. However, we can see the vector of this. So Okay. So I guess our vector is in the opposite direction. That's interesting. Is that because our door is flipped around? I'm not sure. So for some reason, it is going the opposite direction. So if I do this, does it now show what it's showing? All right. And it's supposed to change the length of this thing. Huh. Okay, we're doing something wrong. Let's get some spam in our log and see if I'm doing something really dumb. I might have just gotten the wrong axes here. No, that is definitely changing the value. All right. I don't know if yeah, you guys can see that too. So probably should have that log ignore the def buffer. So something is going still wrong with my place vector. Unless it is local, but I'm not doing. No, there's nothing in here that is making it. Why is that not doing what I think it should be doing? Unless it is that small. No. The thing that I don't get is this is in the positive direction. And we're doing that negative. That could be a problem with the lookat function, though, that I'm doing the lookat function wrong. Oh, hang on. I am thinking of a different project where I did this, where I also scaled it based on that. And in this case, I do not actually care. Right. Okay. So it's only negative because of that. It is indeed positive as we pull back. What we want to do is we do not want to do place vector, but instead we're going to say scale is local position. And I know this looks weird. No, that is actually not correct. Vector 3, 1, 1, and we just want this Z. Why is it? Oh yeah, because we've got a whole bunch of things that we're not using it. All right, let's see if that makes sense. All right. Okay, why is it scaling so small? That's because the default length of that thing is tiny, isn't it? And that was also why it was not positioning very well. So when we look at this vector and we look at this object, that is only 0.1 meter high. So we actually need to do this times 10. Again, this is just to visualize the bloody thing. Oh. So I'm still surprised that why is okay. Because we're turning, we're not doing this right. Okay. That makes sense. All right, so we are going to want to do this differently. Okay. All right. Okay. Seeing we just care about how far away. We don't really care much about the exact offset, I think. So I think actually what we can do is, instead of doing controller global target, we're going to use the controller target, get the local position of that in the door, and use that as an offset. So let's go and see if that makes more sense. All right. So now when I grab that, that makes more sense. So now, even if I move my hand around, that doesn't make a difference. It's purely the distance that my hand is from the door plane. And I know we're eventually going to limit that. We're only going to be able to grab it here on the handle. And we're going to go make that work. Okay. All right. Yeah, that's cool. That is very, very cool. All right. Still wondering whether we should have our logic on the door or on the door handle. Because eventually I want the door handle to be yeah, the debug draw stuff is pretty cool. I probably should look at what's been added to that lately. But, you know, here it's just purely visualizing whether we're getting the right values. And the thing that I have right now is that I'm sort of wondering, like, okay, do I want this logic to be on the door handle? I think I'm going to move this to the door handle. All right. Yeah, let's do that. So we're actually we're gonna go back to what we were doing here and move this into layer 2 so that we're actually not grabbing the door itself. Still want the door to work. But we're gonna add an extra rigid body here, which is gonna become door handle. Okay. Boom. That one actually needs to go somewhere over here. Okay, cool. All right. Okay. This one we need to have frozen. And I'm just going to go and create my own logic here. I'm not going to do anything here. It means that we're going to go and copy this over here. And I'm going to just keep this in place just to make sure that if we somehow grab the door, we don't have any logic there. But eventually I think we're going to remove that because that's not in the layer anyway. But here we now want to do That's actually still okay to have that in there. So now we're just going to go and move that onto the door handle. And then the door handle is just going to be 2 mesh shapes. I'm going to call that mesh 1. It's going to be the cylinder. Way too big. You're going to be 90 degrees. Thank you. And that is going to be 0.05. Is that small is good? It's still too big. That is still way too big. Let's make that so with a radius of 1, that's going to be 2 centimeters. That's fine. And that can be, that's way too small. 3 centimeters. How big was the door again? How big did we make the door? 0.5. So it's going to be 2.5 plus 0.015. 0.4. So that should be clean with the door. Cool. And now we're going to go and do a bar. Mesh. Yep. 0. That is going to be 2.5 plus 0.03 plus 0.015. Okay. And nope, that's the wrong direction. So this, oops, don't do that. This one is going to be 0.03. Yep. No. This is probably going to be. Oh, and of course it's. Okay. No. Oh, okay. I should have done it like that. Okay. Yes. I wonder if that's too big. I'm sure that's fine. It's an ugly door handle, but it works. Let's make it like this. Okay, cool. So, let's go and move this right over here. Actually, let's move that over here. We just want to see that do something. Actually, we're going to probably move it even a bit over here. It's just to see how much we're doing. And then let's give that a grab point. Okay, so that's going to be our left hand. Show hand. Go. Go. Okay, I think our handle is not long enough. So let's make that 2. All right, cool. All right, let's read this. I'm not going to be very precise with this, but let's just see how well we can position that. Actually, pretty happy about that. Actually, I want to go and hide the door for a sec. we can really see what we're doing here. And again, I don't care about precision right now too much. It's just to generally get it into a position that makes sense. Gives the optical illusion that we're actually grabbing this thing. Not even want to have that a bit lower. And our thumb is going to be okay. Huh. I can't actually rotate that into a spot that makes sense. We need something different here. Oh well. Whatever. Our thumb is out of the way. That's the important bit. All right. Flat left grab point. This is going to become our right grab point. We're going to start in the same position. Let's go and let's assume that we can have the same values here. So we're just going to paste it. This time I'm pasting not unique, because I'm going to assume that we can use the same finger positions for the left and right hand. Show that hand. Let's go and hide this one. And oops, let's not do that. Let's move this in position. Good enough for me. Cool. Might move this a little bit more like this so that they're roughly in the same position. Cool. So with that, we also need to go and create collision shape for mesh one. And actually, I don't care about mesh one. I only care about mesh two, to be honest. So let's just go and do that. Let's go move that at the end because we're going to go and clean that up eventually. All right, cool. Let's go and make our door visible again. Now, it's possible that our fingers will clip through the door, but that's fine. So we have our door handle here. So right now we're just doing our calculation. We're doing our vector scale, and that's all. The only reason why this is a rigid body is so that we can actually pick it up. The reason I'm freezing it should be frozen on here. The reason I'm freezing it is because it should then move with our door, because we are handling itself. It should therefore not do much here. So let's go and have a look if that is doing something sensible. Alrighty. So here's our door handle. I'm wondering if we should move our door handle a little higher. Oops, sorry about that. I actually pushed my table over there. All right, so I can degrab this. It's not doing anything. The position of my hand is wrong. That's really interesting. I need to figure that out. Oh, I'm opening the door with my other hand. That's interesting. Okay, so, but that is the important bit. That is working. The other thing that's important is that the door is moving around. That obviously, this is just, the hinge joint just doesn't work very well. And maybe eventually when we look at this, we might completely forego, whoops, my controller there. I might completely forego the using a hinge joint here, and maybe even make the door a static body instead. But yeah, the important bit is that we are making it possible to grab. I'm even wondering if I should make this door handle. I'll make that an animated. No. Animatable body, that's the one that I'm looking for. Let's see if that works. Or if that gives me a problem. I just want to double check if I can actually grab that and if it runs my grab logic. If it does, I'm going to do that because it actually makes far more sense. And the other thing is that I've still got... Yeah, so that is actually working. All right, cool. I'm happy about that. All right, and that might actually be better in this case. Because an animatable body is a static body where you can change the position. A normal static body, when you create that, it registers its position with the physics server, and the assumption at that point is that it doesn't change. And as a result, it caches a whole bunch of things, which makes the physics engine faster. An animatable body, on the other hand, again, is a static body, but it is assuming that you will be moving this. Now, the sync to finish physics, if true, the body movement will be synchronized to the physics frame. This is useful for animating movement via Animation Player. For example, on moving platforms. Do not use together with Move and Collide. Okay. I think in this case, that is all right, but we will have to see. Now, the other thing that obviously I wanted to do, because I wasn't happy about that, is move this a bit higher. Something like this. This is probably good enough. Okay. Now again, I am just not happy with how his hinge joint reacts in Jolt in this case. And again, I don't know if that's Jolt's fault or whether that is just the way that Godot handles a hinge joint, but I'm not supposed to move a door like that. It's just too weird. That's something that I will take up. Okay. All right. So the other thing that I want to do, I'm going to do this. So we are going to make that frozen. All right. All right. And the reason why I'm doing that is I actually don't want the door to open until I unlock it. And that also means that we can actually use our local position in different ways. So seeing that we've got this, I'm actually going to keep that the way that it is. That's just a helper in this case. Well, actually, I don't care about that anymore. So what we're gonna do is this. All right. So that's the position of our hand local to the handle. The first thing that I want to do is the crank motion. So the lower our position is, the more we crank the handle. And there's going to be two things that is going to do. One is just the animation of it, that we can actually move that handle. So we're going to do that first. But then when the handle is fully open, we are going to unfreeze the door. And the other thing is, if we are all the way to the top, and that's actually something that we're going to do on the door body here, or maybe here on process, is if the door handle is not down and the door is closed, we are going to refreeze the door. So it's like the effect that it falls into back into the what is the thing that you're going to call that? Like it falls back into its lock. That's what I'm thinking. So let's first go and do that door handle movement. So that is going to be rotating around the Z axis. All right. So, and we also saw that that becomes lower, right? And the other thing that we need to do, so I think that's we're gonna go to 45 degrees. That's a nice angle to open. Yep, I think so. Okay, yeah, that's great. But how much up is this now? All right, so seeing that we have the vector here now, I'm just gonna move that, oops, down. And that tells us I think that's this value, right? Oops. Why do you not do that? Thank you. Okay, so 366, but we need to do that from here, 3. So basically 0.6. Okay, we're gonna do that on a 0.5. That's fine. So the reason I did that is I just wanted to see how far do I need to move my hand down, because this one is pretty much how far that is up. So, okay, cool. So we are getting, ooh, that's the other thing. As we do this, we are changing. Does that matter? Yes, that matters. That matters a lot. So what we're going to do here, now that can actually be an onReady var. Start transform. And actually we need that in order to properly position our handle. Is transform. So we're going to grab the transform that we have right now, the local transform at startup, which means that we're going to yeah, parent dot global transform start transform. Cool. That now gives us our local position based without the crank applied, which is kind of important. All right. And that means we can now say, what is it, cat? We can now say rotation is vector 3, 0, 0, 0, 0. Jesus, cat, what is wrong with you? Local position dot y times, is that half of pi? Yeah, I think that's half of pi. Now, local position, we're going down. And that reminds me, but we also want this is oh, what is that? What is that called again? not lerp, but can I? Oh, there's no function like that. Okay, what is that again? Smooth step? I think it's smooth step. Smooth step, 0, 1 for positive range is 1, yeah. Yeah, so this should be 0, 0.0, 0.05. There we go. So as we move up to 5 centimeters down, there you go. I'm just messing about with getting a door to work, and getting very annoyed with the fact that we have half a Jolt implementation, and it's doing stupid things as a result. Anyway, let's have a look and see if I'm right about this bit. We put the controls on properly. Alrighty, so I should now be able to grab this. Oh, come on, stop moving. And I should be, no. Oh. Okay, we're going the wrong way, first of all. The other thing is, why does it do that? It makes no sense. Oh, that is because, oops. Okay, that looks like that there's a stupid thing in the smooth snap function then. I have these the wrong way around. This needs to actually be minus 0.5 and then 0. So let's see if that does what I think it should do. All right. Okay, that didn't change a thing. What the heck? Oh, I also need to actually do a let go on this because I need to change the rotation back to where it was when we let go. So, but also why? You know what? I'm just gonna do a plain old clamp for this. Bloody stupid thing needs a name. So this is going to be clamp position dot y between that, and I'm just going to divide it by 0.5. That should really get it to -1 to 0, which is fine. And then I'll do that. There we go. Let's see if that does what I think it should do. Okay, so I can't do it that way. I can't do it that way. That's too far. So I actually want to do a 1/4 of pi. I can do that, but of course the other thing is when I let go, it should snap back in place. So that can be 1/4 of pi. Right. I'm not worried about the let go just yet. Actually, I am. So pick up. Okay, I need to do a process anyway. All right. Hope you feel better soon, Kamau. Okay, where are we with this? Find the next. No, that's not what I picked up by. Okay. Yeah, I guess I can do that. Or probably better to just handle the signals. No, where's the pickup and drop? Pickup objects. So again, same thing as we're talking about before. We don't have trait, so we're just doing this. No, it's on this one. Picked up has picked up as a function. And we just do a pickup by. All right. So we're going to go and do that here. Func picked up. Oh, that's the other one. We should not make it possible to pick it up with two hands. That would be dumb. By XRT2 pickup, and we actually want to do underscore by because we don't care. For that, we're just going to do var is picked up. It's false, and now it's true. And now func. The other one here is oh. Why is it only doing that in this case? That doesn't make sense. I get that we do that here, but this doesn't make any sense. So I think I accidentally copied something here that we shouldn't. So if we drop it, we don't care if, you know, we're still holding it by something else. We want to let it know that it was dropped by that. Or am I only calling picked up if I might have? Where is the picked up one? Is prior. Okay, so that's why I did that. So that does make sense. And that's actually kind of good. So we only give it a picked up when it's the first hand that grabs it, and we only give it a dropped if it's the last hand that dropped it. But it has nothing to do with the player buddy. That was a bug. All right. So in this case, we're going to go say dropped. And I think that was, yeah, that was sending a self as well. So in this case, when we're picked up, we're going to be relying on our custom pickup handler. When we drop, we want to do additional functionality. No, we actually want to run this the moment that we've picked up. So set process true. So we're going to start running our process as soon as we pick it up. And then in our process, we're going to do a couple of things. So we actually, we might care about delta. Here, we're first going to say if not is picked up. Actually, I also want to do a var done is false. No, we don't need to do that there. We do that differently. Okay, so here we're going to say if not picked up, we slowly want to move our rotation z to 0. So we're going to say rotation.z is lerp rotation.z to 0 by delta. So that should make it go back. And I actually want to probably do that like that. but then we also clamp that just in case it shouldn't be, but all right, cool. So that should rotation. That should slowly close it again. So now what we're going to do is say if rotation.z is 0 and we need the same for our door. Gets parent dot rotation. Here it is going to check for the whole word. It should only rotate around the Y, but you never know. But if our handle is closed and our door is closed, we actually want to go and do this. Our parent rigid body 3D is get parent. So let's go do this. If parent and rotation Z, parent dot freeze is true. So we're going to freeze it again. Okay. And at this point in time, we can. All right. And actually what I want to do here is if not freeze to do play full in lock sound. So that's something for later. We're gonna, find a sound bite that's sort of the sound of a door falling closed in its lock, and we can play that at this point in time. So it's sort of like, hey, click, we're back in that. Although we do it if not frozen, we are frozen by default, so it would only do that after we've opened it. So that's also here. So again, this is in the negative. Actually, I want to divide that by the negative, which does mean that we do double negative here. But that's the other one. I want to also do a get parent here. If we don't have a parent, then we return. That should never happen. But we are going to say true because we don't want any sort of error there. And what we can do here is we're now going to say if parent dot freeze and val bigger than, let's say 75. So we've nearly opened it. We're going to say dot freeze is false. So unlock the door, and here lock the door again. There we go. Cool. And obviously, we can enhance on this and say like, hey, if we haven't first turned a key, then we can never unlock the door and that sort of jazz. But yeah, and here it's really important that we actually don't stop our process. We just have, hey, picked up as false. So that is going to slowly close it again. All right, so now we should be able to open the door. We should be able to close the door. We can't just pull the door yet. That's going to be the next thing that we work on. All righty, so. All right, so here we go. All right, so I should be able to do that. And obviously we don't know that we've unlocked it now. Well, oh, that should not happen. This thing is frozen. Why is it still doing something? Unless that at least is working. Oh, why is it so far away from the door? That also doesn't make sense. There is something wrong with that. Why is that positioned there? That's a mistake. All right, let's see how we managed to mess that up. Door handle. Well, that is flush with the door. think that is okay. I'm going to turn that off. I think that is because with the sync to physics, it's actually the positioning in the physics engine that is communicated back, and that's not something we want. We are in full control here. I'm gonna guess that is the thing that happened there. Could be wrong. Okay, that is now exactly on the door. All right, so with it frozen, I actually can indeed not push the door. I can move that around. I can't pull and push yet. Move that. Okay, so it is open now and I can do stupid stuff, but this is so buggy. Okay, but we are, well, that's getting close, but we're not getting the door locked yet. Okay, why not? What's that complaining about? Oh yeah, that's all dumb stuff like that. Okay, let's clear that. Okay, so we're doing something wrong here. Rotation Z, so that could actually be that we never get to 0. So what I actually want to do here is if rotation Z bigger than, then we do that, else 0.0. I also want to go and double the speed of that. Print workflows. Oops. Okay, let's see if that ends up in our log. That also means I'm going to have a look at where our log is. Here. Which text is there? Yeah. Display, this one. What are we using here? Oh, here we go. Oh, that's... I would have to make another thing. I don't really want to deal with that. We're just going to have to move back and see what it does. Okay. Let's have a look. Right, so we know that the door is locked right now. That's cool. Do that. Oh, I was stuck on the thing. All right, so why is it? Oh, it's actually getting a door closed, which doesn't make any sense. All right, so why in this case? If not picked up, then we're going to slowly lower it to 0. If parent and rotation Z is 0. Oh, okay. Here, I actually need to do. We're only going to stop this if we are not picked up. That's why. So because I probably put it back while we're still up, we got the door closed again. If we're not frozen, we freeze. If we're frozen, then we unfreeze. Okay, let's see if that now works more. And it is logical that, yeah, so it's now saying door closed because, yeah, we have our initialization. Okay, that's really interesting. Okay, this is annoying that we can't actually see that while we're doing that, because I wonder if okay, we got a door open, but we don't have a door closed. Do you see it closing? So I'm expecting that to do something. It doesn't make a whole lot of sense. Okay, let's add a little helper for that. Mesh instance. Sphere. There we go. Please be a tiny little sphere. Okay, and let's move that sphere. Really? Ah, come on. Oh, what? That's the wrong one. Here we go. Sometimes these things invert itself, which is really crazy, but it is what it is. So here we're just going to go and say shader material. We don't care. Actually, let's just do standard material. Boom. We just need a material so we can change the color. Yay! That's all we know to do. All right. So now what I want to do here is material override dot albedo color is color. Yeah, that's a yellow. In this case, no, actually, what we're going to do here is we're going to move this over here, and we're going to do parent dot freeze. 0.0 if parent dot freeze else none. So if it's frozen, we're going to make it red. If it's not frozen, we're going to make it yellow. And here, when we open it, boom, boom, we're going to make it green. All right. So green is opened, yellow is closed but not frozen, and red is frozen. Let's see what that does. All right, so you see that it's red right now. Now it's green. And it stays green. Okay. That is not right. Okay. We care about you right now. All right, so when it's picked up, we set process just through. Here we say if not picked up. Okay. Because I'm thinking that there is a point where that gets disabled and it shouldn't. Okay, so the moment we do enable, we start processing. Picked up is true. We're gonna do okay. So with that, we should be able to sort of follow what's going on. We do have a door opened here. stable. So now we unfreeze. And we get in here. Here you're checking. And rotation Z. So that is what we're saying here. Let's see what happens. All right. Green. So door opened. So we got to disable an enable process without a drop first. How do we get picked up getting cold again? Without first getting dropped. That makes no sense. How do we get pickup object called multiple times? That makes no sense. Or do we... But that is just if the other one. And that becomes primary. Very good. I'm even wondering if I should be doing that. Excuse me. Go and do the drop logic, reset everything, and then at the end, if we have the method dropped, we're going to drop it. I don't get this. I don't get this at all. Okay, just for fun, we're going to remove that eventually. Yeah, I really like that little log panel. It's just a shame that it sometimes is hidden behind objects. Okay. Let's see. Oh, breakpoint. Picked up. Oh, haha. Yep. Object body. Okay, cool. Let's do that again. We'll get there. All right. Open. Close. So we're getting picked up door handle lots of times, even though... How are we getting picked up when... That makes no sense. Why is our picked up logic keep getting called? So what are we doing here? Process delta engine data. Picked up and not valid. We're going to drop our object. All right, that makes sense. If our hand is no longer enabled, but with this, we should immediately be outputting dropped. We weren't doing that, so we know. Oops. We know that's not the case. Okay. Is grab. Value threshold. Let's grab. Oh, oh, this is just checking whether we switch grab. Okay. If something picked up and grab is true, then we return. Cool. All right. So I guess I need to. I don't have a nice little be right back screen, but I will need to go for just a second. Let me just look at this. So in that case, we drop. Else, if we weren't grabbing before, and we're grabbing now, that doesn't make sense. So if we have a held object, then cool. Else that. So what is the scenario where because picked up, that gets set when we pick up an object? Yeah. I don't get this. Why? So picked up door handle, enable. Oh, what? Okay, I think that we're getting a false positive here. Our log is actually not working the way that it should. What the heck? Disable process picked up, enabled, door opened, dropped door handle, dropped. This looks correct. This is what I'm expecting. So there's a mistake in our log. It's not. Dirty is false. Entries. You got to be joking, right? Logger, get entries. Oh, it's in here. Get entries. Return that. Really? Why would I not? Why would I not have that default true? Oh, okay. All right, when we get them, we want to clear what we have, else we're going to get the same data over and over and over again. This is a get my latest messages, and there we go. I need to specifically. All right, so I think. Oh, why? So is there get entries? Okay, log get entries. Okay. So we copy our entries, and then we clear our entries. Is it dirty and logger? That message. Okay. So we add it to our entries and then we emit change. And the emit change is just setting our messages dirty to true. Here you say if we have messages, then we do this. Entries. You're not going to tell me that this doesn't do a deep copy, right? Duplicates. Okay, let's make sure that we specifically call duplicates. I have a feeling that when we cleared it, we also cleared our return. It's probably designed to be efficient. Yeah, we now have log things again. Okay, and there we go. Drop door handle dropped. Okay, cool. So our pickup and drop is working properly. So we were just getting confused. All right, guys, I need to leave for just a second. I will be back in a minute. I just need to grab something that was delivered to my door. Be back in a second. Whoosh. Alrighty, I'm back. Okay, so we fixed up our logging logic. That's cool. Let's go and clean up some of the prints that we added that we no longer need. All right, so that one. All right, so what? You want some snacky, please? There you go. Yeah, puss. Okie dokie. I'm keeping these in because I want to know why that is not properly working. Oh, that obviously. Blah, blah, blah. That was obviously negative, so it never got to 0 probably still. All right, let's see if that works. All right, let's see. Blink, 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 blink. Okay. All right. Oh, our hand is stuck on the door again. Oh, that's so stupid. However, we are not getting there, and I have a feeling so yeah, that goes to negative. So let's do a print here and say actually let's do an else if rotation.z smaller than 0. Close. All right. So I'm actually guessing that that is not doing what I hoped that it would do. Because that obviously should give a local rotation based on our door node. Well, we know that we go through here the first time because we have our disable process running at least once. Actually, I want to call this picked up because that is what this is, picked up. And I actually I'm not sure if I want to send the buy here because we might be dropping it with a different hand. The other thing that I quickly want to do, by the way, is on these is make sure that we've got exclusive turned on. That means that we can only grab this with one hand. All right, so let's see if we get that closed. Hold. Obviously, that should only be when we let go of this. Okay, door opened, dropped, closed. So yeah, that is definitely happening. We are definitely getting to 0. All right. All right, this is going to spam like crazy, but I don't care right now. We're going to go and, oops. Run that. Well, those are a lot of zeros. All right, so we're getting parent. We know that rotations of Z here should be 0. See if that makes a difference. Come on, Bass. Yeah, so. Oh, look at that. It was almost 0. Floating point values. Hooray. All right. So in this case, let's go and make sure that it's absolutely 0. We lock it. That's obviously our test. Okay. All right. So with all that, now it's time to make the door open and close. So here's the thing. The way to properly do this is to apply a force based on how far away the hand is from the door handle. So we have already calculated that over here. Although I do think that I need to actually move the position of this. And what I actually want to do for that is I want to do a new build 3D just as a temp. So we're going to go and put that there. We're going to move all of this here so that now we can move the door handle this is wrong. To the middle here. Okay. So, cool. Now we can move all these back. Okay, with that, our door handle is there, but we have these grab points slightly different. That's fine. Let's see how far. So this is door handle, the Z direction. Yeah. Okay. I'm going to make sure that these are both on the same position. So we know that that's how much we need to subtract from this. What do you think? That's a good one. Here's the track of that. Always forget what the grab offset actually is. Is that the offset to the center? Which is why it was changing for that. The reason why I am right now not entirely sure is because we're comparing the origin of the hand to our door handle position. But the problem is that the origin of the hand isn't our grab point. So the problem is do we care? Actually, where are we? This one is positioned correctly. So maybe I just need to take the position of that. That might work. So instead of that one, we grab, pick up. All right, look. And I probably need to then apply my hand offset, but oh, does that not change? No, so that doesn't work. So, I'm guessing that that does not. Dang it. Okay. I think that I probably need to take that transfer into account from there, because that's the location we're basically tracking. And that's the location where our hand pickup is related to. Okay. I think I know what to do now. So what we're going to do here is times pickup transfer. All right. Okay, that's still working. Cool. All right. So, because that's the problem that I'm having, right? I need to push it further in, but now that is because we are now level with where our pickup is. Very cool. So now we can actually properly adjust that. Cool. So, all right, we got that all. Boom, boom, boom. So now we can look at basically what our grab point is. So I'm just going to hard code that for now. We're going to say local position dot c is local position dot c minus that. Hash position right. Okay. Okay. All right. 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 Okay. Let's see if that makes sense. So now our vector error should have no length when we're positioning that. So we can see, yeah, that's pretty much there. Close enough. So now what we're going to do is obviously when we're open, depending on how far we do that, we're now going to apply a force to our door. It should allow our door to open. Except that, of course, that stuff still happens. Yeah. And what we just saw, the door just going crazy, is when I let go of the handle, my hand was just in the way of the door. That's basically what's going on there. So that's something we need to figure out as well. But all in good time. Yeah, that's just because we're not using U, and we are using U. We're not using U, and we're not using delta yet, but we're about to. And the door. Cool. All right. So now what we're going to do. If not frozen, so this is where it gets funky. Because here we want to do current dot apply. Is it force or impulse? Which one's the applies a positional force on the body? A force is time dependent and meant to be applied. Exactly, that's the one that I want. So we have the force and we have the position of the force. So let's just go and say force vector 3 is vector 3, and our position, just to make it easier to read what we're doing. Force position is already taken, so we do that. Now our position is actually going to become times vector 3 0. So we want it to be on the door at this distance from center. This is where, this gets really crazy. We actually need to have our position rotated in global space, but local to the origin of our door. So our origin of the door is there. So we're getting the position over there in relative to here, which is just weird. We now have it local. So we need to go and say parent dot bases times position there. So I'm taking the y and z vector out to make sure that that position is purely on the x, but we're rotating that, and that needs to be global bases in the global position of our. Why is that bar? In the global orientation of the door, but local to the origin. Now we need to do our force. So this is the same sort of deal. We're going to have a force purely on that. So here we're going to do our local position dot z. So how far away from the door are we? Times delta. And excuse me. Force strength. Let's give that a name. Boom. So that's something that we're going to go and play around with. And that's going to be a export var, so that we can set it. Let's just start with 10 and see what that does. Might be way too little, but we just go and get and see what that does. All right, cool. All right, and that also needs to be in this orientation. Now we could actually simplify this by saying we want that in the Z, and we just want to do times that. So that's a simplification. Just we don't have to do a full rotation multiplication. We just go and do that. The door logic. Well, I don't know yet. Obviously, I do want to have this sort of functionality working in combination with the hinge. But to make this a component is going to be tricky. So for now, it's just part of the demo. But yeah, I do eventually want, what we basically had in ExtraTools 1 called interactables. Eventually, I do want that same sort of logic in here. So let's go have a look. We can open it, but we're not applying force. It's possible that I'm applying it in the wrong direction. Let's see, where is my door? Yeah, that should be the Z one. Should be good as well. Let's just print these out and see if they make sense. Oh, what? We broke something. This is me. Huh? Oh, that's fine. Yeah, can't load the script that way. Now the script doesn't work, and now suddenly it's being treated like a static object. Alrighty, and that explains why our ball was the wrong color. Green. All right. Position. Okay, that's probably because we rotated. Okay. Does that make sense? All right, so. Oh, that isn't there. We need to actually look in the world. Yeah, so we flipped around. So in local space, we have indeed x negative, so that's correct. And then minus 0.9, that seems to be correct too. All right, Rantang, thank you for joining this long. I hope you learned something. All right, so maybe the force is just too little. Possible. All right. Let's apply a bit more force to the door. That could still be too little force. Oh, that's right. Mm. Let's go a bit more. Yeah. Okay. Oops. Wink. Wink. Yeah, it's very obvious that we are not applying enough force. Whee! All right. Funny, funny, funny. Okie dokie. Still thinking that this picked up only happening when it's primary. Does not make sense to me. Again, this is not a two-handed thing, so it doesn't matter. But yeah, so seeing that we are sending self, I'm going to take that out. I'm always going to be sending this. And it's then in the logic inside of this that someone can say, you know, am I being held by more than one hand? Or am I still being held by the other hand? And react accordingly. Because with this, what I want to do is to helper add collision exception. That's a good one. Yeah, that's one, but what's the other one? Collision hands. Okay. So can I get the collision hand? So I'm going to control our target. I think I'm gonna wanna just add that in here. Okay. Go here. If collision ends, then we want this and parent. So when I add the door, so that as our hands hand leaves, we don't get this, hey, the door is being hit by the hand. We have a little bit of delay there. And the other thing that I'm thinking about doing is with the remove collision is that we immediately check I think I'm going to add a minimum duration here. Yeah, we're gonna go and do a countdown here, but I'll add that later. I want to make sure that we allow collisions to happen for a little bit after dropping something. And actually what I want to do here is this. And that's all right. If we somehow do end up grabbing with two hands, that's actually a ref counter in collision in the collision handler here. So it doesn't actually remove the collision exception until both hands let go, because we're doing it with the same parent. All right, so we got all that. We got all that. I actually want to do this a little bit better. We're going to do that by saying local. Actually, let's go clamp this. Local position 0.0. How far away from the door do we go? Let's do it like that. 2 centimeters, is that enough? Now we're going to go for 5 centimeters. That's for strength. All right, this is overkill, but okay. So now, because we're going to, oops, divide by that, our strength can be lower, but only by that, because I do want it to be. So this also means that if we go very far away, we don't suddenly increase the strength like crazy. So now we are not doing enough strength again. That's interesting, because that should ramp it up. All right, let's do it like this after all. Even though we made that a lot stronger. Interesting. Sorry, I don't have my hand proper on the little thumbstick. I actually need to make that. Oh. Okay, why? This makes no sense. Oh, because I should also be allowed to go negative. And the force was way too much this time. All right. So let's do 500 then. This time we're going to go and clamp between minus 0.5 and 0.5. All right. Good. Yeah, that works pretty well. There's a little bit of we can actually do that by giving the door. Cool. All right. So one of the things that we want to do here is we're actually going to give it a decent angular damp. We should not have any linear motion, but whatever. Right. This would actually be a good trick. I don't know if this needs to be positive or negative. Let's give it a little bit of positive force. So that's going at a constant torque. And the reason I'm doing that is I want the door to fall closed by itself. So we've got more than enough strength to do that. You can now see that the damping is making sure that we don't get crazy movement. Well, almost. I guess it only sometimes works. All right, so I'm having a feeling that... Oh. Look at that, we made it full closed. Okay, so whatever that angular torque is doing is not doing enough. That's fine. Okay. So something I do want to do right now is that. Also, let's double check if we don't. Yep, that's cool too. All right, cool. So I don't think this actually works, and I'm gonna just leave that. I think I'm just gonna do a physics process. If not, freeze. Okay. You guys. All right. So. All right. What I want here is a minus delta times minus Leggy. That's probably going to be way too much. And this needs to be... Wait. No, that's actually not parents. That is actually this one. Okay, I think the... Oh, I locked it. Didn't I not? Yep, I locked it again. I think that close strength is overpowering it. Okay. Let's see. Or is it because I was 200 at 200 is just not enough? That's also possible. So look. Yeah, I'm just not doing it strong enough. That's what you get when you change too many things at the same time. You don't know which change is the culprit. All right, let's see. All right. Yeah, so is that my closing force or what we can do? Oh, yeah, boom. All right, so closing is not enough, and I think a 500 is not enough. 400. Let's go to 600 on you. And there's a 200 on you. And that 200 might be way too much, but we definitely have it now that we can open, close, let go. All right. Not freeze. Well, it's closed now. Okay. Okay, so all right. So the problem now is that yes, we have a force that is now attempting to close the door again. We don't need you. So I think that we should only be doing this when we don't have the door handle. And maybe it's something that I want to do in here. If not picked up, we do that, we do that. Okay, let's go and move this in here. Okay, we're gonna go and have parents over here. And I'm gonna say if parent and parent isn't frozen. Parent, oh, what? Sometimes that pop-up is annoying. Okay, so now we're saying if we're not picked up and we do have a parent, we are going to make the door close. All right. All right. So that should now mean that is nicely. So now when we are opening and closing it while holding it, it's not going to do some. No, this is still so weird that it has this. The dampen thing should deal with that. Oh, okay. I do think the closing force is too much, but it closes the door automatically. I'm wondering if we really want that, but as far as because this is where we can then get into a situation where the door closes on us before actually ready for it. So this is what I find so interesting. So now we don't have enough strength on the door to actually get it closed. Oops. I think I'm going to take that logic out. I actually don't like it. I'm not going to do this. Okay. So yeah, this strength seems to be needed to overcome our dampening, but at that point in time, our dampening just becomes too much. That's really weird. Anyway, that said, the middle lever stayed there because that's kind of cool to see. I do want to get rid of the vector because that is no longer something that we really need. All right, I am going to delete that one because there's no reason we need that. Clear. Which that also means that we should be able to so we can delete this one, remove, there we go. So yeah, so I'm going to keep the state in there just for example. Do I need to have still all the prints? I'm going to get rid of the prints. Okay. So all right, so this is just if I, oh yeah, because it's frozen right now, so I can't do that. So that actually kind of, so this is really, yeah, I don't really get why the dampening isn't really helping us out there. Of course, the reason why it initially goes wrong is yeah, we need to add our own little dampening logic there, I think. And then obviously this dumb. Anyway, I do like the fact that we have the closing logic working. Yeah, you know, all the principal stuff is here. So now it works fine again. Yeah, I don't get why it sometimes oscillates and sometimes doesn't. Because this is now work. Ooh. What the heck? So yeah. It's definitely working. But there are lots of things to improve that I do like. You know, it falls closed and then it falls into its lock. Okay. I think that is enough for anyway, Varix, yeah, kind of yes, no. A lot of the physics interaction that we're doing in XRTools 2 is kind of somewhere between Half-Life Alyx and Boneworks, in the sense that we're doing a lot more with physics, which is also one of the reasons why I'm having so many stability issues. But at the same time, I am trying to restrict how we're doing certain things to indeed get more like a Half-Life Alyx sort of interaction. I don't actually know how much Half-Life Alyx relies on physics as opposed to as opposed to just direct manipulation. So we did much more direct manipulation in XRTools 1. So kind of what we're doing here with the door handle is we grab the door handle, but we're moving the door handle with code. So we're not relying on physics to move the door handle. We are relying on physics to move the door. And the physics for the door would be perfect if the hinge joint worked correctly. But the hinge joint, for some reason, does not constrain the door properly. And I do not know how much of that is due to shortcomings in Jolt, or whether there is just an issue with the way that we are applying forces, that it is overpowering. Because the force logic right now is still fairly straightforward in the sense of we're just looking at the distance between where the hand is and where it should be, and the more the distance, the more force we apply. And while we do limit the force to some extent, yeah, there are problems there. The other thing which really, as you notice, is that oscillation that we have with a lot of things. And with there, I probably need to look at the current angular velocity of the door and limit the force that I'm applying depending on where I think the door will be based on its current rotational speed. Now, that would actually be fairly simple to do. Might actually be a good one to just add in, that we, when we're looking at our script here, that might actually be a simple one to add in. In here right now to calculate, we are looking at we're looking at our start transform of where our door handle is on the door, and we're applying that to the global transform of the door. But we can adjust this global transform based on the current angular velocity of the door. That's probably a really good idea, and then do our calculation based on that. Yeah, let's see. It's parents.global transform. Oh, so let's see. This is Godot. Yes, this is Godot. I used to use this, but I recently switched to Unity because I wanted a more versatile programming language as the logic core. Yeah, Godot supports C#. So if you want to do C# with Godot, you can do C# with Godot. So that's interesting. All right. So what we now need to do is look at our angular velocity. All right. So, okay, let me think of that. I think that does not change the position. That just, okay, so parent t dot bases is parent t dot bases. Actually, let's do first, because we need that anyway. Len is parent dot angular velocity length. If len bigger than 0.01. Again, I probably should have a little bit of a bigger value there, but whatever. Or smaller, I should say. Let's just do that. Okay, so now what we can do is this becomes bases parent.angular velocity divided by len. That gives our angle, and then len times delta. that should give us how much we are rotating. And I think it is then, sorry, times our faces. And that means that we should now be able to say, oh, that is, hold on. No, I think the angular velocity isn't global. I'll soon see if that works. Let's see if that improves anything. Hey, Rods, how you going? Is all right. All right. Let's see if. Yeah, that does help. So. Okay. Yeah, it's still a little bit of oscillation when we do like that, but at least we slow down instead of it being crazy. Boink, and it's locked again. Yay. Yeah, that's a lot better. So now we're basically looking at its current velocity, and we're adjusting the door position based on where we predict where it will be next frame. And we're on, that means that our pulse that we apply is now adjusted accordingly. It's really cool. All right. Yeah. And when we close the door locks itself again. All right. That is a lot better. All righty. Well, in the end, simply put, you need to use the engine that you're most comfortable with, right? So if you feel that Unity is, better, better fits your needs and fits your experience, then why switch engine, right? You got to have a good reason for it. You got to switch to Godot if Godot is something that you enjoy using. I do think that giving C# a try in Godot, and C# is built in, it's just a different download. Although we are porting things to a GD extension, simply because that gives us more flexibility. But it's a choice. But anyway, bottom line is, if you're enjoying Unity, keep using Unity. There's no reason to not to. Rods, this is definitely ready to play with. There's a lot of functionality in here, and I actually would love people like yourself to start doing stuff with this. And hold on, let me go and look this up. There we go. So that is where it is. On my GitHub, Godot XR Tools 2, although we may change the name of that at some point. Obviously, everything that I've done in this stream isn't in that repo yet, but I do plan to upload it. It has many of the basic functionality that XR-Tools 1 has, but there's still a lot in XR-Tools 1 that hasn't made it into XR-Tools 2 yet. One of the biggest differences of XR-Tools 2 compared to XR-Tools 1 is that we are not doing the inheritance that XR-Tools 1 has. So instead of having to create a special scene for a rigid body that you want to be able to pick up, you now just do a normal rigid body. So if you look at, it's in the world. If you look at one of these boxes, this is just a normal rigid body with a normal collision shape and a normal mesh instance. We do have these grab points, although they are disabled right now for the box. So this is the other thing that's different. If you do add a grab point, which in this case I've done, I've done on this box, so you can see the hands there. They are enabled, so we grab it actually on those grab points. But if those are disabled, or if you don't add them at all, it will try and figure out the best position to grab that. There's a helper note here that you can define a little bit more logic around this, and it'll probably have different behaviors or more behaviors at some point. However, the whole point is that those are optional. So you can customize how something is grabbed in XR, but if you do not, then the default logic just works. And that means that you can have a game that you build for non-XR, where you have everything just as normal rigid bodies, and whatever methodology for your player controller you do to grab those things will work. But then if you switch to XR mode, the same objects still work. And that's the whole thing is. So you can grab any physics objects. There is then a nice little thing that I've been working on and that I demoed at the start of my stream, and that you can test out with this thing and these things here, is you can grab rigid bodies, you can grab physical bones. They all result in, hey, I can grab those and I can move them around, and it applies those forces to the object that you've picked up. But if you pick up a static body, or if you pick up a rigid body that is frozen, it will actually affect the positioning of the user. So just to demo that. So these things here on the wall are just normal static bodies. And there's nothing special with these other than that, again, I've added grab points to them just so that I can position the hand. But as you can see, now when I move my hand, I'm actually climbing. And when I grab that one, I actually can move between two. There's still a bug in here. It's actually, its default rotation is wrong. So I still need to figure that out. And then I wish when I let go, well, in this case, the jump was because I was obviously colliding with something. And it pushed me away as a result, because I do have some push logic in there. I'm actually very surprised at that. Maybe it was because, I let both hands go at the same time. But again, the nice thing is that any static object that you put in the world can do. So in theory, I could actually grab this wall, but I've got this wall in a different physics layer to prevent me from grabbing the wall. This little ladder here, same thing. So this is actually doesn't have any grab points. So that's our default grab logic. So I can grab it there, and I can grab it there, and I can grab it there. Oops, I didn't grab that correctly. So grab it there, grab it there, grab it there, and I can just slowly move myself up, and then yay, I'm on the platform. So there's still a little stability stuff that I need to fix and figure out. No fall damage, I can fall down. Same, by the way, with the table. It's also something that I can grab, and I can just move myself around by moving my hand around. It's even to a point that if you do not use, because that's the other thing that I did here, is when we look at the player body, there is a default scene here called the XR2 character body scene that just has a standard setup with my locomotion handler, Raycast body, which is the thing that allows you to be off the ground and that you can actually walk upstairs and stuff like that. And then obviously your origin. The physical movement handler is to make sure that if you physically move around your room, that the character body actually follows you. So right now I'm sitting down. I can't really demo that, but if I would be walking around my my room, then that all works. And then obviously I've got my default hands. And obviously my camera. So this is a basic setup, but you don't have to use this. You can pick and choose which parts of XRTools you want to use. So let's say that you don't want the locomotion handler and the Raycast body, but you want the rest of the logic. You can just leave those out, or you can create your own character controller with just the bits that you want to use. So for instance, if you're doing an MR application, you would just want to have the origin 3D and camera 3D and the collision hands. You wouldn't want to do any of the other things because you don't want virtual movement there. The other example that I gave earlier in the stream was if you want to do something like Gorilla Tag, you might not want the locomotion handler and the Raycast body. You might still want to have the physical movement handler, but now you just make your well, your scenery is just a static body. You make a small collision shape for your character body, and now you use the standard pickup logic to just walk around the world. I actually want to make a demo scene for that. I haven't got a loader for that yet. Right now I'm just dropping everything in this. As far as hand tracking is concerned, yes, I can't show it off because I'm using the frame at the moment. The frame doesn't have hand tracking, but it seamlessly switches between controller tracking and hand tracking. The only thing that you obviously have to keep in mind with hand tracking, a lot of the locomotion stuff doesn't work. So your direct movement won't work because you don't have inputs for that. That is something that I do want to look at some point in time to create virtual inputs for that sort of stuff. But by default, that's not there. But obviously, if you want to do like an MR application, you don't care about that. You wouldn't be using the locomotion handler. You would just have an origin 3D and a camera 3D and your hands. This collision hand, by the way, is an object that I'm quite proud of. This does all the hand logic. So it draws the mesh. It does the ghost hands that you saw. You can toggle everything on and off, so you don't have to use it, but you can. It has the fallback logic if you don't have hand tracking, so that it still animates the hands. It actually, on controller tracking, it's using inferred hand tracking, so we're still using the hand tracking that it's actually kind of nice to show. This is something that works not just on frame, but works on a number of controllers, including like index controllers. But you'll see that I can actually move my individual fingers. It's not perfect, but based on the capacity things, I can actually move those. Same with the thumb, depending on where I am, that thumb moves. And obviously index finger moves. I have control over, right now I've got the index finger set to a curl setting. I think that is a motion range. It's still set to full, so I'm not quite sure why it didn't fully extend, but yeah, so it has support for that, and it does that because we're using OpenXR's hand tracking, and many of the, well, at least Meta's runtime and Valve's runtime both support inferred hand tracking, and it will do that. But for headsets or runtimes that don't support that, we do have a fallback that we just use the trigger and grab action to animate the hand ourselves. And it's not as nice as this, but it does a decent amount of work. This also has all the posing logic in there, so that's what drives. For instance, when we look on the world, and we go and grab something like this one, for instance. So when we look at our hand here, you can see that I've posed those. So those fingers, I've determined what the layout of those fingers are, or the angles of those fingers, and that system. So you can see that the finger poses are set here. That system will make sure that we position the hand in that way when we grab that object. So there's a lot of stuff in there. A lot of stuff is similar to Xrtools 1, just in many ways more polished. But there are a lot of rough edges to this yet. This is still very much in early beta, maybe even alpha, depending on how you want to look at that. But yeah, bottom line is, if you want to play with it, go and play with it, because the more feedback that I get, and the more help I get with people saying like, hey, I've got a fix for this bug that you've got in here. I would be more than happy about that. The other thing which is different with Xrtools 1 is that the main branch on this is actually just a plugin. So there's a demo branch on this, and I highly recommend that you clone the demo branch, not the main branch. And you'll see in add-ons that the main branch is actually submoduled here. And the idea there is that if you create your own application, is that you submodule Godot Xrtools in the add-ons folder so that you can easily apply updates and stuff like that. If you don't want to do that, obviously we're going to be doing releases. There is a a test release here. So this is from a couple of days ago, and you'll see that there is actually a zip file for Xotools 2, and that actually has the correct add-ons folder structure. So this is prepared for the asset library. Asset store nowadays. For those who don't know this yet, the asset store is, well, still officially in beta, but we are nearing official release, and that is actually in 4.7, directly accessible from the Godot interface. So this asset library tab is actually going to be replaced by the asset store tab. Mostly works the same, but yeah, that zip file will then be presented on the asset store eventually, and obviously that's the other way that you can install it. But yeah, important to know, if you want to test with this, if you want to play around with this, highly recommend to recursively clone the demo repository or the demo branch, and that will bring in both this demo that I've been playing with and the add-on, and that shows you how it all works. On the main branch, there are some instructions here around how to use installation. So here you can see that the default suggestion is to submodule it into your project, but I get that not everybody's comfortable with submodules. Why is that turned? So yeah, there's a little bit more information in. This is not a drop-in for Xotools 1, so you can't just say, oh, I was using Xotools 1, can I just delete Xotools 1 and put Xotools 2 in place? That does not work. So while you could do a refactor if you really wanted to, I recommend that if you are already using Xotools 1 is to keep using Xotool 1 and to only use Xotools 2 for a new project. And then, learn the difference, because it is structurally a different approach that I took here. There are no documentation pages yet or anything like that. I have not gotten anywhere near that. I do want to do that at some point in time, but yeah, not yet. What else can I say about this? Yeah, other than that, really, the stuff that's currently in there is mostly locomotion, hand interactions. There's no UI stuff in here yet. I am still going back and forward on what I want to do there. And in that thing, there are some things in here that are just not finished yet. So yeah, there is a 2D UI class in here, but it doesn't work yet. So I haven't actually done anything like that. Yeah, most of it is all about it. Oh yeah, so there's a prefabs folder in here that has that character body 3D scene in there. So if you want to use that as is, you just dump that into your scene. Just like Xotools 1, it has the whole staging system. Again, optional. You don't have to use the staging system, but I do highly recommend people use the staging system. So yeah. Oh, that's all sorry, I'm looking at the wrong thing. These are going to disappear. I'm going to re-implement that at some point. But I do plan to have a number of different configurations for different player setups here eventually. So this one is our default character body one that uses a character body. I'm probably going to replace the static player rig with an actual static player. So static player rig is meant for if you want to have a simulator like a car or stuff like that. But I might also have a prefab at some point for MR where we leave out the character body, and we're totally setting things up for an MR environment. I'm thinking about adding one at some point where you have a rigid body as the player. So that's something that I'm actually, with a private personal project, I'm working on that. Yeah. So yeah, there's a whole bunch of stuff in here that is starting to really work very well. But yeah, pretty cool. Pretty happy with it. Alrighty. Cool. I've taken the door right now as far as I want to take it. Yes, there are still some issues to solve. Some things that I don't think I can solve that just needs to be solved in the physics engine, which is really annoying. But I've got in there the things that I really want. If the physics engine remains a pain in the butt. Sorry to say it. I can't say it any other way. I may eventually go and redo this to not use joints, but just use my own sort of logic for manipulating the door position. Obviously, at some point in time, I want to see if I can change this to be some sort of components that you can create your own interactions. Because right now it's completely focused on a door. The other handle situations that would be nice to do. But yeah. Do I enjoy making VR games in Godot? Yes, very much so. Else I wouldn't be doing this work. It can get frustrating around especially physics. There are many rough edges in physics in Godot. It's one of the reasons why XRTools 1 makes much less use of physics. Obviously, we are using the physics engine there, but just not as not to the level that we're doing here. This is all physics driven. But yeah, there are some rough edges there, and that's something that I need to talk more with the physics guys about. I think a lot of that is caused by us only recently switching over to Jolt and just not having implemented everything around there. No, I have not played around with Unity. For me, I wanted to learn and work on actually implementing XR from the ground up. So I chose an engine that didn't have XR support, that I could add XR support for. So that's now already over 8 years ago. So yeah, I've never really had the need to really do anything with Unity. I do know a lot of Unity developers that I've talked to over the years. And obviously, Unity is ahead of us performance-wise and rendering-wise. But for XR itself, and I'm leaving the physics side out of that equation a little bit. For XR itself, most of the feedback that I've gotten is that people like what we're doing better than what Unity has done. It's just that Unity's toolkits are further along than the toolkits in Godot. So if you know what you're doing and you can scratch build things, things really, really work well in Godot. But if you rely on toolkits, then there are quite some limitations that you need to be comfortable with working. Does GDScript show any performance in 3D? I really hope that you don't write shaders in GDScript. That's why you use shaders. And that's the point, right? That's what people don't understand when they're talking about performance. If you use GDScript for what it is intended to be used for, performance isn't an issue. When you are looking at controlling your game with GDScript, that code isn't in the performance path, in the path where you would notice an impact on how well your game runs. But it allows you to build a game in a fraction of the time than it would if you do the same in C# or C++, because you save yourself so much time with compiling and restarting a game. The fact that you can run your Godot game and live change the scripting language and fix things on the fly while your game is running saves you so much development time. So when you then get into a situation where you do need to write some logic that GDScript is not very good at, a really great example, for instance, is if you write logic to procedurally generate meshes. That is, for instance, something that GDScript is not performant enough in. Well, not on scale, at least. For simple things, sure, but on scale, no. At that point in time, when you want to do that sort of thing, then you switch over to C# or C++ and build it in an extension. But even there, you can build the prototype in GDScript, find out which parts of GDScript are actually a bottleneck for your application or for your game, and just optimize only those parts. You save so much development time if you take that approach. And then, indeed, what Rods says is also very important. And I actually had a discussion about this a little earlier in the stream around, for instance, raycast nodes and raycast logic. A lot of people in Unity are coming from Unity are used to writing raycasts in code. And when you suddenly execute a loop of 100 raycasts in code, you're suddenly going to go like, why is this slow as crap? Well, because that's just not something that GDScript is good at. But you can put 100 raycast nodes in your scene and they will work. And suddenly you just have some code that interrogates those nodes and suddenly it's fast. So it's also about knowing where do the weaknesses lie, where do the strengths lie, what are the right way to do things, how much can you can you offload to the internals of the engine through composition, and how much do you actually do in code. And that is really the important thing around this is you use GDScript for what it is meant to be used for, and performance won't be your problem. You try and do things that GDScript is not very good at. Yeah, that's where you need to start looking at, okay, do I write that bit of code in a module, or am I taking the wrong approach here? Is there a better approach in Godot for achieving the same goal? And that's, that's the way off. The way that I look at it is execution performance is only one factor. You also need to look at the performance of you as a developer. What do you develop fastest in? And I'm a C++ guy, right? I have done C++ since I was 14 years old. I love C++, and I love working on the engine in C++. I would not want to write my game code in C++. That's just stupid. Yeah, it'll be fast, but it'll take me 10, 20 times as long to get where I want to go. And I don't need those bits to be fast because they are not my bottleneck. And that is the thing that people forget here. It's not about purely execution performance. It's also how fast can you work as a developer and which parts actually need to be optimized, especially with games. 90% of your game runs on a GPU, doesn't even execute C++ or GDScript or C# or any code. 90% runs in shaders on your GPU. So half the time your CPU is just sitting there like, I got nothing to do. And yeah, so it takes twice as long to do something, execute something in GDScript than it would in C#. Well, if it's not doing anything either, it can take twice as long and you don't even notice it in your frame rate. So yeah, it is really a matter of, where lie your bottlenecks, and make sure that there you start looking at, okay, where do I actually need to optimize? And optimization usually comes at the end. It doesn't come at the start. At the start, even AAA studios, except when they are building their games, the performance won't be there from day one. They want to build the game first, then they start looking at, okay, what parts of my game are now slow? What parts do I need to optimize? And most of that optimization will be in the assets, making sure there was a really great example the other day. I can't remember which game it was. But this was a game that was running fine, AAA game, and someone took the time to optimize it by simply optimizing assets to go from, a multi-gigabyte installation to, a few gigabytes of things just by optimizing texture sizes, meshes, stuff like that. Made the game a whole bunch faster. It's not a single line of code that was changed. It was purely assets and shaders and textures. Optimize those to make the game run fast. So yeah, I can talk about that for hours. And yeah, Rods, indeed, if you target quests, it is more important. I do agree with that. If you're building something for such low hardware, the same with if you're building a game for mobile, that's where where it does matter a little more, where you're more likely to run into performance issues. But even there, the performance issues will be mostly on the rendering side, not on the game execution side. So there are efforts to compile GD scripts. There are a couple of modules and extensions out there that that transcompile GD script to C or C++. I'm not convinced that that is where your fix lies, because you would just do things differently when you rewrite them as a C++ module or things like that. So I don't know. I'm fairly skeptical about that. What I do like about compiling GDScript, and the one thing where any runtime language, not just GDScript, is a problem, is that obviously compiling your code does make it harder for people to steal your code. That's that is something that I'm personally not too worried about, because I open source almost everything that I write anyway. But yeah, if you are really concerned about IP, then compiling obviously does make it harder. It doesn't make it, it doesn't safeguard you, but it does make it harder for people to steal your code. So there is that. But yeah, in the end, I am, performance-wise, I am a big believer of build something first, look where your pain points lie, and then optimize your pain points. You will find you save so much time in development because you only do the difficult stuff where it matters. And that's my experience. Yeah, that's everything that I got for today, guys. Cool. I'm just waiting and seeing if there's any more questions in chat. Also, I'm going to call it a day and have some dinner. Alrighty, everybody. Then I'm calling it there. Thank you so much for watching. I hope it was informative. I hope it was useful. And we will continue on this later. Bye, everybody.